You have already traveled through time today, not in the way the stories describe. No machine, no blinding light, no arrival in another century. But from the moment you woke up this morning to this moment right now, you have moved through time in the only direction anyone has ever moved through it. Forward, always forward. Never pausing, never reversing, never choosing the speed. Most of the time you don't notice this. Life fills the hours and the movement feels natural, like floating downstream in a current so familiar you forget the current is there at all. But occasionally something happens. A photograph, a scent, a song from years ago, and you feel the river. You feel how fast it is moving. You feel everything it has already carried away. And for a moment, the simple fact of time becomes the strangest and most overwhelming thing in the universe. Physicists have spent lifetimes trying to understand what time actually is, not how to manage it or spend it wisely, but what it fundamentally, physically, actually is. And the deeper they have looked, the stranger the answers have become. Time may not flow at all. The past may still exist. The future may already be written. And the present moment, the only place any of us ever actually lives, may have no measurable duration whatsoever. Over 25 chapters, we are going to follow time to the edges of what is known and several steps beyond, through paradoxes that collapse on themselves, through physics that bends everything you assumed was solid, through the deeply human experience of being creatures who remember the past and imagine the future, but can only ever touch the vanishing instant between them. No time machine is required, just stillness, and a willingness to let the river show you how strange it has always been. Chapter 1. The river that only flows one way. There is a film of a glass falling from a table and shattering on the floor. You have seen versions of this many times. The glass tips, falls, strikes the floor, and breaks into pieces that scatter across the surface. Now, imagine the same film played in reverse. The pieces gather themselves from the floor, assemble into the glass, which rises from the floor and returns to the table where it came to rest, unbroken. Watching the reversed film, you know immediately, and without deliberation, that it is wrong. Not that it is technically impossible to film or to display, but that the sequence it shows cannot happen in the real world. The pieces do not gather, the glass does not unbreak. The sequence has a direction, and the direction is not reversible. Now here's the thing that should unsettle you slightly. The physics that governs the atoms in the glass does not know this. At the level of individual atoms and molecules and the forces acting between them, the equations that describe what they do work equally well in both directions. If you ran the physics equations that describe the behavior of the atoms in the falling glass forward in time, you would get the shattering. If you ran the same equations backward in time, you would get the reassembly. The mathematics does not have a preferred direction. The atoms do not know which way is forward, and yet the glass only ever shatters. The pieces only ever scatter. The film of the reassembly is always unmistakably wrong. Somewhere between the physics of individual atoms and the experience of a glass falling on a floor, time's direction became real. Not just a convention, not just a label applied to the sequence after the fact, but a genuine and irreversible feature of how the world unfolds. The river only flows one way, and the physics of the individual water molecules does not explain why. This is one of the deepest and most genuinely unresolved questions in physics. Not unresolved in the sense that researchers are working on it and will probably have an answer soon. Unresolved in the sense that the leading physicists who have spent careers thinking about it have not arrived at a consensus, and that the explanations that exist are more like frameworks for pointing at the puzzle than solutions to it. The arrow of time, as it is called, the unidirectionality of the way the world unfolds, is something that every human being experiences directly and continuously, and that the fundamental laws of physics do not seem to require. The explanation that has the most traction in the physics literature is thermodynamic. It involves a quantity called entropy, which is a measure of how many different arrangements of a system are compatible with its large-scale properties. A glass intact is a highly specific arrangement. There are very few ways to arrange the atoms that produce a glass. A glass shattered into 100 pieces scattered across a floor is a much less specific arrangement. There are vastly more ways to arrange the atoms that produce broken pieces scattered across a floor than there are ways to arrange them to produce an intact glass. The shattered state has higher entropy than the intact state. The second law of thermodynamics says that in isolated systems, entropy does not decrease over time. The world moves from lower entropy to higher entropy, not the other way around. The glass shatters and the pieces scatter because there are more ways to be shattered and scattered than there are ways to be intact. And random processes in a large system tend to move toward the states that are most numerous. The unbroken glass is a rare and specific arrangement. Everything tends away from rare and specific arrangements toward more common and less specific ones. This is why things fall apart rather than coming together. Why heat flows from hot to cold rather than from cold to hot. Why the universe is not running backward. But this explanation, while it is the best available, has a feature that physicists find deeply puzzling. The second law depends on the system starting in a low entropy state. The glass can only move to higher entropy because it started as an intact glass. If it had started as already broken, the pieces would not spontaneously reassemble, not because of the second law, but simply because they are already in a high entropy state. The question the second law does not answer is why the universe started in a low entropy state in the first place. Why was the Big Bang the beginning of everything, an extraordinarily low entropy event that has been increasing ever since? Why did the river begin at a source rather than in the middle, moving in both directions, or at the sea, having no particular direction to flow? The physicist Roger Penrose has calculated the probability of the universe beginning in the specific low entropy state that it did begin in, and the number he arrives at is so small that it has no ordinary analog. Not improbable in the way that winning a lottery is improbable. Improbable in a way that no lottery with any number of tickets could represent. The specific arrangement of the early universe, the arrangement that gave entropy somewhere to go, that gave the river its source, was an arrangement of extraordinary and almost unimaginable rarity. And the question of why it was that arrangement, rather than one of the vastly more numerous high-entropy arrangements that the early universe could have been, is a question that the physics of entropy does not answer. Some cosmologists have proposed that the low-entropy beginning is a feature of quantum fluctuations in a much larger universe, that our observable universe is a bubble in a larger structure, where conditions vary enormously, and our bubble happens to be one where the initial conditions were low entropy. Others have proposed that the low entropy beginning is in some sense necessary, that the existence of observers capable of asking the question requires a low entropy beginning, because observers capable of asking the question require complexity, and complexity requires a history of increasing entropy from a lower starting point. Both of these proposals are speculative in ways that exceed what current physics can test. What remains, after all the proposals, is the river. It flows in one direction. Everything in the physical experience of living confirms this. The memories are of the past and not the future. The causes precede the effects. The glass breaks and does not unbreak. The sequence of events moves from what was, to what is, to what will be, and the from and to are not interchangeable. The physics equations do not know this. The river does not care what the equations think. It flows the way it flows. And the puzzle of why is one of the genuinely deep puzzles that the universe has left sitting at the edge of what we know, like a glass balanced on the edge of a table. Chapter 2. The Grandfather You Erased. There is a thought experiment so simple that it can be stated in a single sentence, and so profound that it has occupied philosophers and physicists for nearly a century without resolution. You travel back in time and kill your grandfather before he meets your grandmother. Your parent is never conceived. You are never born. You do not exist. But if you do not exist, you cannot travel back in time. And if you cannot travel back in time, you cannot kill your grandfather. And if you do not kill your grandfather, he meets your grandmother, your parent is conceived, you are born, you travel back in time, and you kill your grandfather. The loop closes on itself and immediately reopens. It has no stable resting point. Every conclusion undermines the premise that produced it. This is the grandfather paradox, and in its full form, it is not a puzzle about killing grandfathers. It is a puzzle about whether the past can be changed, whether causality is something that time travel must respect or can violate, and whether the universe is the kind of thing that can contain contradictions, or whether it is structured in ways that prevent them from forming. These are not small questions. They touch the foundations of what time is and what the relationship is between the moments of the world and the things that happen in them. The simplest version of the paradox assumes that the past is changeable. The time traveler arrives in the past and does something. The doing changes what subsequently happens. The The grandfather dies who did not previously die, and everything downstream from his life is altered. This version of time travel is the one that most stories about it assume, because it is the version that produces interesting plots. If you go back and change things, the things you change have consequences that propagate forward, and the propagation is the story. The hero goes back to prevent the catastrophe. The villain goes back to cause it. The world is different because someone went and changed it. But this version, followed honestly, produces the grandfather paradox as a structural feature rather than an edge case. It is not just that killing your grandfather is impossible. It is that any action in the past that prevents the time traveler from making the journey they already made is impossible. And there are many such actions, some of them dramatic and some of them very small. If you sneeze at the wrong moment and a stranger catches your cold and is too ill to attend a particular party where they would have met their future spouse, and that meeting failing to occur has downstream consequences that eventually include your non-existence, then your sneeze was impossible. The class of impossible actions is potentially very large, not limited to dramatic interventions. Any alteration to the past that changes the history that led to the time traveler making the journey cannot have occurred if the journey occurred. One response to this is the fixed timeline theory, which holds that the past cannot be changed, and that the time traveler who goes back in time finds themselves already in the past that was, not in a past that can be altered. The grandfather paradox dissolves under this interpretation because the time traveler cannot kill the grandfather, not because a force prevents it in some physical sense, but because the grandfather did not die at the time traveler's hands in the past, and the past is what it was, and nothing that happens in it can make it otherwise. The time traveler who goes back to kill the grandfather will find that they fail, one way or another, because they failed one way or another, because the grandfather lived to produce the children who produced the time traveler. This interpretation has a quality that is philosophically satisfying in some respects, and deeply uncomfortable in others. It makes the past coherent and prevents the paradox, but it also makes the time traveler's visit to the past a kind of imprisonment. They can do things, but only the things they did, which are already part of the history they came from. They cannot change anything because everything is already set. The story of the past includes the time traveler's visit, which was already there, which has always been there, which is simply being experienced from the inside rather than known from the outside. The time traveler is not a visitor to the past, they are a feature of it. There is a specific vertigo that comes with thinking this through carefully. If the past is fixed and the time traveler cannot change it, and if the time traveler's actions in the past are part of the fixed past that produced the present from which the traveler departed, then the traveler's presence in the past was always part of the causal structure that produced the present, which means the time traveler may have caused some of the things they observed, may have been the mechanism by which certain events occurred that were part of the history that led to their journey. The grandfather paradox becomes not a contradiction, but a loop, a causal circle that has no beginning and no end, where the time traveler's visit to the past was both caused by the past and contributed to it. This is the Bootstrap Paradox, which sits adjacent to the grandfather paradox and is in some ways its mirror image. Instead of a causal chain that undermines itself, it is a causal chain that loops back on itself without a clear origin. The time traveler goes back and gives their past self a piece of music. The past self learns the music, composes nothing, plays what the future self brought. The music has no composer. It appeared from nowhere, was transmitted to the past, and was always there. The information came from somewhere, but the somewhere is the future that received it from the past, that received it from the future. The loop is internally consistent in a way the grandfather paradox is not. It has no contradiction. It has instead a kind of ontological impossibility, a thing that exists without having been created, that was never authored, that simply is because it always was. The second major response to the grandfather paradox is the many worlds interpretation, in which the time traveler who goes back in time does not return to their own past, but to a branching timeline that diverges from their own at the moment of arrival. The grandfather in this new timeline dies, but the timeline in which he died is not the timeline from which the time traveler came. The traveler's home timeline still exists, with the grandfather still alive, still producing the descendants that produce the traveler. The traveler has not unmade themselves. They have created a new world in which a version of their grandfather died, and they now exist in that new world rather than the one they left. This resolution preserves consistency. No contradiction arises. The grandfather's death produces a branching timeline where the traveler is never born in that branch, but the traveler came from a different branch where they were born, and they continue to exist as the immigrant from one world to another. The branching is the resolution. The paradox cannot form, because the past being changed is not the task the traveler came from. What none of these resolutions fully addresses is the felt impossibility of the original paradox. The reason the grandfather paradox has persisted as a puzzle is not that physicists and philosophers cannot generate possible responses to it. They can and they have. The reason it persists is that each response requires accepting something that strains the ordinary understanding of what time and causality are. The fixed past requires accepting that the time traveler's choices are not really choices in the past. The branching worlds require accepting that the past the traveler changed is not their own. The causal loop requires accepting that some things exist without having been caused. The river that flows one way, which the previous chapter described, becomes a river that bends back on itself and joins its own source. Or a river that splits into branches whenever something touches it. Or a river that was never really flowing at all, but simply is, all of it, all at once, and the experience of its flowing is something the water itself mistakes for movement. The grandfather is not easily erased, even in thought. The loop keeps forming. Every attempt to close it opens it again. Chapter 3. The you that was already there. There is a version of time travel that has a quality quite different from the dramatic intervention stories that the idea usually generates. Not the hero arriving to prevent the catastrophe, not the villain going back to cause it. Something quieter and stranger than either. The version in which the time traveler arrives in the past and discovers not that they are a newcomer to it, but that they were always there. That the past they are visiting already contained their visit. That the history books, had they been thorough enough, would have mentioned them. Not as a time traveler from the future necessarily, perhaps as a stranger who appeared at the edge of a significant event and then was not seen again. Perhaps as a figure in a crowd in a photograph. Perhaps as a voice that someone heard and could not account for. The traveler was already there. The visit was already part of what happened, and arriving is not changing anything. It is completing something that was always incomplete in the account, but was never absent from the reality. This is the logical consequence of the fixed timeline interpretation of time travel that the previous chapter described. If the past cannot be changed, and if time travel is possible, then every moment in history that a traveler will ever visit already contains that visit. The presence is permanent from the moment it occurs. The history that included the time traveler's visit is the history that always was, not the history that was and then was altered by the arrival. The history, the one that produced the present, that produced the traveler, that produced the visit, that was already in the history. The implications of this are wider than they first appear. Consider what it means for the totality of history if time travel is eventually developed, by human beings or by anyone else in the universe capable of it. Every moment of the past, from the very beginning of whatever we mean by the beginning, becomes potentially populated by visitors from every subsequent period of time. The Cretaceous period, if time travel is possible, and if anyone from the subsequent billions of years ever visits it, already contains those visitors. The moment of the Big Bang, if it can be reached, if the physics of very early times permits the kind of stable space-time geometry that a time machine might require, already contains everyone who will ever visit it, folded into its first moment as an invisible feature of its extraordinary complexity. This is not the same as saying those visitors are visible or detectable. The traveler who arrives to observe an event and does not intervene in it, who watches from a distance and departs, leaves traces that are tiny and perhaps unmeasurable against the complexity of everything else that is happening. The tourist who visits ancient Rome without speaking to anyone and without touching anything has been to ancient Rome and is therefore part of its history, but the part they are is vanishingly small against the scale of the city and the century. The past that contains these visitors is not obviously different from the past that does not, at the level of what the historians can reconstruct from the surviving record. But at the level of what was actually there, issue of any given moment in history would be enormous. Not just the people who were born in that time and lived in it, but every visitor from every subsequent time that time travel reaches. The 14th century, already a time of extraordinary complexity and suffering, including the Black Death, would also contain observers from every future century that developed the capability and the interest to look back at it. Not altering it, not able to alter it, but there, watching, arriving and departing in ways that left no record, because they were careful, or because the traces were too small, or because the records that would have captured them did not survive. There is something that sits uneasily with this picture from a physical perspective. The matter and energy that constitute the time traveler come from the future and arrive in the past. The conservation of energy and mass within the observable universe would seem to require that this arrival be accounted for. Matter does not appear from nowhere. If a traveler materializes in the 14th century, the mass that constitutes them was somewhere in the 14th century, in some form, before and after the visit. The physics of how this is managed is part of what makes time travel theoretically difficult, beyond the question of what causality permits. The traveler who arrives from the future is bringing something from the future into the past, and the universe's accounting of matter and energy would have to accommodate this in ways that our current physics does not provide a mechanism for. The many worlds interpretation sidesteps this problem by positing that the traveler does not arrive in their own past at all, but in a branching timeline. The mass they carry was not in that timeline's past, because the timeline did not previously contain them. Their arrival is the beginning of the divergence. But the fixed timeline interpretation, in which the past is what it was, and the traveler's arrival is already part of it, must somehow account for where the traveler's mass was before the traveler arrived. One proposed answer involves the traveler departing from the future and thereby removing their mass from the future at the same moment it appears in the past, so that the total amount of mass in the universe at any given moment remains constant, because the traveler exists in only one time at a time. The departure and the arrival are the same event viewed from different temporal vantage points. This is internally consistent, but requires a specific structure for how time travel works that is more constrained than most fictional depictions assume. The you that was already there raises a specific question about identity that sits alongside the physical questions. If the fixed past contains the time traveler's visit, and if that visit is already woven into the causal structure of everything that followed the visit, then the traveler who is sitting in the present, deciding whether to make the journey, is deciding something that may already be decided. Not in the sense that they feel compelled, in the sense that the past which already contains their visit is the past that produced the present in which they are sitting. And if they choose not to go, the past will not contain their visit, and the past that does not contain their visit is a different past from the one that produced the present. But they are in the present that was produced, so they will go. They will go because they went. The decision to go is the past that produced the present that produced the decision. This is not the same as saying the decision is not a real decision. From the inside, from the position of the traveler sitting in the present moment and weighing whether to make the journey, the decision is entirely open. There is no felt compulsion. The future is not yet fixed in any experiential sense. The sensation of choosing is genuine. What the fixed timeline interpretation says is that this genuine sensation of choosing will result in a choice whose outcome is already embedded in the causal structure of history, because history is what produced the moment of choosing. Whether this is a form of determinism is a question that philosophers of time and causality have not agreed on. The loop does not determine the outcome in the way that a domino determines the next domino. It is something stranger than simple determinism. The outcome determines the conditions that produce the choice that produce the outcome. The causality runs in a circle rather than a line. The circle does not have a beginning. It simply is all at once, a complete thing. You were already there. You went because you had been because you went. And the decision to go was made by the person who was already there, deciding. Chapter 4. The moment before the first moment. There is a question that children ask with the kind of directness that adults have usually learned to avoid, because the directness leads somewhere that the adult has learned to be uncomfortable with. What happened before the beginning? Not before the beginning of this particular thing, or that particular era, or the current arrangement of whatever currently exists. Before the beginning of everything. Before whatever the earliest moment is, the moment that nothing preceded, the moment that was not itself preceded by a moment. What was there then? What does then even mean when there was no before for it to refer to? The question is not naive. It is one of the most serious questions that has occupied cosmologists and philosophers and theologians since human beings developed the capacity for this kind of questioning. It is serious in a specific way that distinguishes it from most serious questions. Most serious questions are ones where the difficulty is in finding the answer. This question has an additional difficulty that comes before the finding of the answer. The difficulty of whether the question as asked is coherent at all. Whether asking what happened before the beginning is like asking what is north of the North Pole. Not a question that is hard to answer, but a question that contains within its structure a confusion about the nature of the thing being asked about. Stephen Hawking used exactly this analogy. Just as there is no geographic location north of the North Pole, because north is defined relative to the pole, and beyond the pole, the concept of north no longer applies, there may be no time before the beginning of time, because before is defined relative to time, and in the absence of time, the concept of before no longer applies. The question, what was there before time began, assumes that before is a meaningful category in the absence of time. If time began, there was no before, not a before that was empty or dark or waiting, just the absence of the category. The question dissolves rather than being answered. This is philosophically satisfying in a certain way, and deeply unsatisfying in another. It is satisfying because it provides a clean response to what seemed like an impossible question. It is unsatisfying because it does not tell us anything about what the beginning was, or why there was a beginning rather than no beginning, and it does not explain why there is something rather than nothing, which is the question lurking underneath the question about the moment before the first moment. The dissolution of the before question does not dissolve the why question. The cosmological model that has the most empirical support describes the universe beginning approximately 14 billion years ago in an event of extraordinary density and temperature, from which space, time, matter, and energy all emerge together. Not matter and energy exploding into a pre-existing space and time themselves beginning with the matter and energy. The beginning is not an event that happened in time, it is the beginning of time. The singularity, if the equations are followed all the way back, is the point at which the description breaks down, where the curvature of space-time becomes infinite and the physics ceases to provide meaningful predictions. It is not a description of what happened at the beginning, it is a description of the limit of the description. The physicist and cosmologist Alexander Vilenkin proposed a model in which the universe emerged from nothing through a process of quantum tunneling. In quantum mechanics, particles can tunnel through barriers that classical physics would consider impenetrable, appearing on the other side without having traversed the space in between. Vilenkin proposed that the universe could have tunneled into existence from a state of absolute nothingness, from no space, no time, no matter, no energy, nothing at all. The quantum tunneling process in his formulation does not require a pre-existing time in which to occur. It is the origination of time as well as of everything else. The tunneling is not something that happened, it is the process by which happening began. The difficulty with this proposal, which its author acknowledges, is that quantum mechanics as we know it is a theory that operates within space-time. The quantum tunneling that it describes involves particles moving through potential energy barriers within a pre-existing framework of space and time. To apply quantum mechanics to the origination of space-time itself is to apply the theory outside the domain for which it was developed and in which it has been tested. Whether the mathematics still applies in this domain, or whether it is being asked to do work that exceeds what it was designed for, is a genuinely open question. The proposal is not obviously wrong. It is not obviously right. It is at the frontier of what the current physics can address. Roger Penrose has proposed a model called conformal cyclic cosmology, in which the universe goes through an endless sequence of what he calls aeons. Each aeon begins with something like a Big Bang and ends in a cold, dark, distant future in which the only remaining entities are massless particles, which in his formulation become indistinguishable from the initial state of a new Big Bang. The ending of one aeon and the beginning of the next are the same event viewed from different perspectives. There is no moment before the first moment in this model, because there is no first moment. The sequence of aeons extends infinitely into the past and infinitely into the future. The question of the beginning is answered by removing the beginning. What exists has always existed in some form, cycling through states that include the extraordinarily low entropy state that we recognize as a Big Bang. This model has specific predictions about the cosmic microwave background, the ancient light that fills the universe as a remnant of the early hot dense phase, and Penrose and his collaborators have claimed to find features in the data that are consistent with the model's predictions. The claims are contested. The features may be artifacts of the analysis rather than genuine signals. The model is serious enough to have generated empirical investigation, which distinguishes it from purely speculative proposals. What all of these proposals share is the attempt to answer a question that may be unanswerable by the methods that are available to human minds. The question of what existed before the beginning, or whether the question is coherent, or whether there was a beginning, is a question about the conditions that produce the physics that human beings use to ask questions. The tools of investigation are part of what is being investigated. The physics that would describe the moment of origination is the physics that originated in that moment. The mind that asks about the first moment was produced by the process that began with the first moment. There is a category of question that sits permanently outside the reach of the methods that would answer it, not because the answer does not exist, but because the asker and the asking are inside the thing whose origin is being asked about. The fish cannot observe the water by swimming to the edge of it. The edge is more water. The water is all there is, in every direction, to the full extent that the fish can reach. You are inside time. The question about before time is asked from inside time. The answer, if it exists, is outside time. And outside time is not a place that anything currently inside time has the equipment to reach. Chapter 5. The Clock on the Mountain. There are 2 atomic clocks. They are extraordinarily precise instruments, accurate to within a second over billions of years, synchronized to read the same time before the experiment begins. One of them stays on the ground. The other is taken to the top of a mountain, or placed on an airplane, or sent into orbit, and left there for a period of time, and then brought back and compared to the clock that stayed. The clocks do not agree. The one that traveled has recorded less time than the one that stayed behind. Not because of any mechanical error or instrument failure, because less time actually passed for the clock that moved. Time ran slower for it, not in any metaphorical or approximate sense. The clock that traveled is behind the clock that stayed because it experienced fewer seconds, fewer genuine moments of duration than the clock it is being compared to. This has been measured, not inferred or predicted or proposed as a theoretical consequence of an elegant mathematical framework that has never been tested against reality. Measured directly, with real clocks, in multiple experiments across several decades. The difference is tiny in the experiments that use airplanes and mountaintops, a few hundred nanoseconds over the course of a day's flight. But it is real, it is consistent, and it agrees with the predictions made by Albert Einstein's theories of special and general relativity to extraordinary precision. The GPS satellites that make navigation possible on every device that uses location services must account for this effect, or they would accumulate errors that would make them useless within days. They are corrected for it constantly. Your phone's location accuracy is maintained in part by accounting for the fact that time runs faster for the satellites than for the devices on the ground below them. Einstein's insight, which changed the understanding of what time is more profoundly than any previous idea, was that time is not the fixed and universal backdrop against which events occur. It is not a river that flows at the same rate everywhere, indifferent to what moves through it or where. Time is woven together with space into a 4-dimensional fabric that physicists call space-time, and the properties of that fabric are affected by 2 things: motion, which was the subject of special relativity, and mass, which was the subject of general relativity. Both of these distort the fabric in ways that change how time flows for different observers. The motion effect is the one that most thought experiments about relativity address. 2 twins, one of whom travels at a large fraction of the speed of light, and one of whom stays home, will find on reunion that the traveling twin has aged less, not because of anything about biology or perception or the subjective experience of the journey. The physics is the same for the traveling twin as for any other object in the universe. Less time passed for them, their cells divided fewer times, their heart beat fewer times. If they kept a diary, it has fewer entries. The asymmetry is real, and it comes from the fact that the traveling twin underwent acceleration in changing direction to return, while the staying twin did not. Motion through space, particularly acceleration, changes the rate at which time flows for the thing in motion. The gravitational effect is the one that the clocks on mountains and in satellites measure. Mass curves spacetime, and the curvature affects the rate at which time flows. Deep in a gravitational well, time flows more slowly. On the surface of the Earth, time flows slightly more slowly than it does in orbit above the Earth. On the surface of a neutron star, where the gravitational field is enormously stronger than anything on Earth, time would flow dramatically more slowly than it does here. Near the event horizon of a black hole, where the gravitational field becomes extreme, time would flow so slowly that a distant observer would watch an object falling toward the horizon appear to freeze and never actually reach it, while the object itself would cross the horizon in finite time as it experienced time. The two observers, one falling and one watching from a safe distance, would have genuinely different accounts of what happened, both of which are correct within their respective frames of reference. This is not a paradox in the same sense as the grandfather paradox. It is a feature of how the universe works. The resolution to the apparent contradiction between the two observers' accounts is that there is no single absolute account. There is no vantage point from which time flows at a universal rate, against which all other rates of time can be compared. The flowing of time is always relative to something, relative to the observer's state of motion, relative to their position in a gravitational field. The universe does not have a master clock against which all other clocks are measured. Every clock is measuring something real. The something real that different clocks measure differs depending on where the clock is and how it is moving. The implications for time travel are specific and interesting. If time flows at different rates in different places, and if the difference can be made large enough, then the relativistic effects already constitute a kind of time travel into the future. The twin who travels at a large fraction of the speed of light and returns home has traveled into the future relative to the twin who stayed. Not into a possible future or a probable future, into the actual future. The staying twin has aged more. Events have occurred for the staying twin that have not occurred for the traveling twin. The traveling twin has, relative to the staying twin, skipped forward in time. This is not theoretical. The clocks on the airplanes demonstrate it at tiny scales. The GPS satellites demonstrate it continuously. In principle, with sufficient velocity or sufficient time in a strong gravitational field, the effect could be made as large as desired. What this kind of time travel into the future does not provide is any mechanism for time travel into the past. The relativistic effects all move time in one direction, the forward direction, simply at different rates. The twin who traveled fast aged less than the twin who stayed, but the traveling twin still aged. Time still flowed forward for both of them. The difference is in how much forward, not in whether forward. The clock on the mountain does not tick backward. It ticks forward more slowly than the clock in the valley. The relativity of time does not make time bidirectional. It makes the forward direction of different clocks diverge from each other in ways that depend on their histories of motion and gravitational exposure. There is something in this that changes the understanding of what aging is. You do not age at a universal rate determined by some cosmic clock. You age at a rate determined by your history. Where you have been and how you have moved determines how much time you have experienced. Two people born at the same moment do not age at the same rate. They age at rates that depend on the entirely specific paths their bodies have taken through space-time. The difference is tiny for any human life as it is actually lived, because the velocities and gravitational differences available to human beings produce effects that are measurable by atomic clocks, but not by human experience. But the difference is real. The clock on the mountain is ticking faster than the clock in the valley. You are somewhere between the two, moving at your own pace, through a space-time that bends and curves around the mass of everything near you, and the time you experience is yours alone, not shared by anyone, even the person standing next to you. Chapter 6. The decision that was already made. There is a moment happening right now that feels from the inside like a genuine opening, a fork in the path, a place where the next thing could go one way or another, and which way it goes depends on something that has not yet been settled. The sensation is specific and physical. The sense of weighing, of considering, of the balance tipping and then tipping back, of genuine uncertainty about what will happen next, precisely because what happens next depends on a choice that has not yet been made. The experience of deciding is one of the most intimate and most constant features of conscious life. It is what agency feels like from the inside. It is what distinguishes being a subject, a thing that acts, from being an object, a thing that is acted upon. Now introduce the time traveler. Not hypothetically, not as a character in a story being discussed at a careful philosophical distance. Introduce the time traveler as a real feature of the situation. Suppose that someone from the future has already visited the period of time you are currently in. Suppose that the visit occurred, that it is part of the fixed past that produced the present you are inhabiting. That the record of the period, if it were complete, would show the visitor. The visit was already there. The history already included it. Everything the visitor did during the visit was part of what happened, and what happened is what it was, and none of it is changeable because the past is the past. In that case, the person you will become, or someone who knew the person you will become, or someone connected to the consequences of decisions you are about to make, may have already been present during the period you are living through, may have already known during their visit how the decisions you are feeling your way through right now came out, may have looked back at you from the future with the specific knowledge of hindsight, knowing which way the fork went, knowing what you chose, knowing the downstream consequences of what right now feels like an open question. The question that this generates is not primarily about the mechanics of time travel. It is about whether the feeling of deciding is doing what it appears to do, whether the experience of weighing and considering and the balance tipping and tipping back is genuinely the process by which what comes next is determined, or whether it is something more like the experience of following a script that has already been written, delivered with such conviction and such detail that the performer never suspects they are not improvising. The determinism debate is older than time travel as a concept. The question of whether the future is fixed, whether the laws of physics operating on the state of the universe at any given moment determine a unique subsequent state, whether every event is the necessary consequence of the events that preceded it and the rules that govern how events relate to one another, was being argued before Einstein was born, before quantum mechanics was developed, before any of the specific physical frameworks that give the question its contemporary shape had been formulated. The argument is old because the question is fundamental. If the laws of nature are deterministic, if they entail a specific future given a specific present, then the future is already contained in the present in a sense that makes the experience of deciding something that requires explanation. Newtonian mechanics was fully deterministic. Given the positions and velocities of all the particles in the universe, and the laws governing how forces act between them, the entire future of the universe would follow necessarily and could in principle be calculated. The French mathematician Pierre-Simon Laplace articulated this with famous clarity by imagining an intellect that knew the positions and velocities of everything in the universe at one moment. For such an intellect, he wrote, nothing would be uncertain, and the future, just like the past, would be present before its eyes. The intellect has come to be called Laplace's demon, and it represents the logical consequence of Newtonian determinism applied to the universe as a whole. Quantum mechanics complicated this picture in ways that remain contested. The quantum state of a system evolves deterministically according to the Schrödinger equation, but measurements of quantum systems produce results that are probabilistic rather than determined. The interpretation of this is one of the deepest and most disputed questions in the foundations of physics. In some interpretations, the quantum indeterminacy is fundamental and real, meaning that the future is not fixed even in principle, and Laplace's demon cannot exist because the information required to construct it does not exist. In other interpretations, including the many worlds interpretation, the apparent randomness is a feature of the observer's perspective, and the underlying dynamics are deterministic, with all possible measurement outcomes occurring in different branches of the wave function. The question of whether quantum mechanics saves free will from determinism depends heavily on which interpretation of quantum mechanics you accept, and the interpretations are not currently distinguishable by experiment. The time travel version of the problem has a specific structure that is different from the determinism debate in at least one important way. The determinist argument is about whether the causal structure of physics entails a unique future, given a unique past. The time travel argument is about whether the existence of information from the future being present in the past is compatible with the experience of genuine decision-making in that past. These are related but not identical questions. A universe could be deterministic without containing any time travelers, and the question of whether decisions in such a universe are genuine is a question about determinism. A universe with time travelers who have already visited every period raises an additional question about what it means for the past to contain information about its own future. If the past already contains the consequences of decisions that feel presently undecided, then the decisions have been made. Not in the experiential sense, not in the sense that the person making them has already made them and is simply reenacting the making, in the sense that the outcome is part of the fixed causal structure of history, that what comes next is already woven into what came before, that the feeling of the balance tipping is the experience of a scale that has already settled, even as it appears to be settling. The person who finds this conclusion too uncomfortable often reaches for the point that the feeling of deciding is itself a cause. The experience of weighing and considering is part of the physical process that produces the decision. The neurons firing in the pattern that produces the experience of deliberation are the same neurons that produce the behavior that follows the deliberation. The decision is not made somewhere above the neurological process and then implemented by it. The neurological process is the decision. The experience of it is what the decision feels like from the inside. On this account, the feeling of deciding is not an illusion, it is the thing itself. But this account does not escape the time travel problem. If the decision is the neurological process, and if the neurological process has already produced its outcome in a past that is already fixed, then the outcome is settled, even though the settling feels like a process that is still ongoing. The feeling is genuine. What the feeling is tracking may not be what it appears to track. The decision that was already made is being made right now, by you, who does not know it was already made. And the not knowing is not a mistake. It is the experience of making, which cannot feel like anything other than what it feels like. Chapter 7. The Newspaper from Tomorrow. There is a man sitting at a desk with a newspaper. The newspaper is dated tomorrow. He received it today, through a mechanism that the thought experiment does not need to specify precisely, only to stipulate that it arrived from the future and that its contents are accurate. He reads the stock prices. He reads the sports results. He reads the news stories about events that have not yet occurred. He now possesses information about tomorrow that he could not have obtained by any other means, and he is going to use it. He will invest on the basis of the stock prices. He will place bets on the basis of the sports results. He will make preparations for the events the news stories describe. The newspaper has changed his day. It has changed what he will do and what will happen to him, and perhaps what will happen to others who are affected by his changed behavior. And then tomorrow comes. The events occur. The stocks move as the newspaper said they would. The games end as the newspaper said they would. The news happens. And at some point in the day, someone takes the newspaper that has now become today's newspaper, puts it in the mechanism that sends it back in time, and delivers it to the man at his desk the day before. Where did the information in the newspaper come from? Not in the practical sense of who wrote the articles and typeset the pages. In the causal sense. Every piece of information in the newspaper describes an event. Every event has causes. The stock prices are what they are because investors made decisions, which were made on the basis of other information, which came from somewhere. But one of the investors was the man at the desk, who made his decisions on the basis of the newspaper, which contained the stock prices, which were partly determined by his decisions. The newspaper is simultaneously the cause of the man's decisions, and the record of the events those decisions contributed to. It is its own ancestor. It was not caused by anything outside the loop. It simply is because it was, because it will be, because it is. This is the Bootstrap Paradox in a form that makes its structure impossible to miss. The previous chapter on the Grandfather Paradox mentioned it briefly, but the newspaper version makes it vivid in a way that the abstract statement does not. Information exists in the loop. Real, specific, useful information about stock prices and sports results and news events. This information is not random. It is precisely correlated with the events it describes because it is derived from those events. But it was not derived from those events in the straightforward causal sense in which information is usually derived from events. It was derived from those events by being sent back in time before those events occurred. After which it caused the events it was derived from, after which it was sent back in time to cause them. The philosopher's term for this is a causal loop. A sequence of events in which each event is caused by the events that follow it, which are caused by the events that precede them, which are caused by the events that follow them, with the chain bending back on itself until it meets its own beginning and closes into a ring. Nothing in the loop was caused from outside the loop. Everything inside it caused the things that came before it in time, which caused the things that came after it, which caused it. The closed causal loop is logically consistent in a way that the Grandfather Paradox is not. The Grandfather Paradox contains a contradiction. Killing the grandfather both does and does not occur, depending on which part of the causal chain you are examining. The causal loop contains no contradiction. The newspaper exists. It is sent back. The man reads it. He acts on it. The events occur. The newspaper is produced from the events. The newspaper is sent back. Everything is consistent. Every event has a cause, and every cause has an effect, and no event contradicts another. The loop is sealed. self-consistent, and completely coherent. What the loop lacks is what philosophers call an explanation. Not an explanation in the colloquial sense of an account of what happened, in the sense of a reason why. The newspaper contains specific stock prices. Why does it contain those specific stock prices, rather than different ones? The answer is that the stocks moved to those prices on that day. Why did the stocks move to those prices on that day? Because of investor behavior, including the behavior of the man at the desk who read the newspaper. Why did the man at the desk invest as he did? Because the newspaper said the prices would be those prices. Why did the newspaper say those prices? Because the stocks moved to those prices on that day. The question has been answered in a perfect circle that never touches ground. David Lewis, the philosopher who wrote most carefully about the logic of time travel, used the term inexplicable to describe events in causal loops. Not inexplicable in the sense of being mysterious or poorly understood, inexplicable in the precise sense of lacking an explanation that traces the event's existence to a cause outside itself. The newspaper's content is internally explained by the loop. It is not externally explained. Nothing outside the loop is responsible for the specific content of the newspaper. The content simply is what it is, because it was what it was, because it will be what it is. This has a specific and strange implication for the concept of information. Information normally comes from somewhere. A description of an event is information derived from the event. The description is the downstream product. In the causal loop, the description and the event are part of the same self-sustaining system. The description is derived from the event, and the event is shaped by the description, and neither is prior to the other in any ultimate sense. The information in the newspaper was not generated by any process outside the loop. It was not authored. It was not calculated. It was not observed and recorded. It simply is, because it has always been, in the loop that contains it. The physicist and philosopher Kip Thorne, who has written technically about the physics of closed time-like curves, uses the term information from nowhere to describe this feature of causal loops. The information exists without having been created, in the ordinary sense of creation, where something brings something new into existence. It is uncreated information, a pattern that persists without ever having originated. What this does to the concept of knowledge is interesting and uncomfortable. The man at the desk knows the stock prices. He knows them because he read them in the newspaper. The newspaper contains the information because the stocks move to those prices. The stocks move to those prices partly because he acted on the information. His knowledge is not knowledge in the ordinary sense of a belief that is both true and justified by evidence that was produced independently of the belief. His knowledge is a feature of a self-referential system in which the knowing and the known are aspects of the same closed structure. He knows what he knows because what he knows caused what he knows. The newspaper on the desk is accurate. The information in it came from nowhere. The man who reads it acts on it. The actions produce the events. The events produce the newspaper. The newspaper is sent back, and nothing in the loop was ever caused by anything that was not already inside it. Chapter 8. The twin who came back younger. There are two siblings born on the same day. They grow up together, age together, go through the ordinary progressions of a shared childhood and adolescence in the same household at the same pace. On their 30th birthday, one of them boards a spacecraft. The spacecraft accelerates to a significant fraction of the speed of light, travels to a distant star, turns around, and returns to Earth. The journey takes what feels to the traveling sibling like 5 years. They return at the age of 35, having experienced 35 years of life. The sibling who stayed on Earth is not 35. They are 60. 30 years passed on Earth during the 5 subjective years of the journey. The twins stand looking at each other across a gap that has nothing to do with estrangement or disagreement or the ordinary drift that separates people who live apart. The gap is temporal. They began at the same moment and they have arrived at different moments. The staying sibling has 25 more years of experience, 25 more years of memories, 25 more years of the accumulated weight of living. Their body has aged by an amount that the traveling sibling's body has not. Their cells have divided more times. Their telomeres are shorter. Their face carries the record of 3 additional decades that the other face does not carry. This is not a story. It is a consequence that follows from the physics of special relativity with the same certainty that the Pythagorean theorem follows from the axioms of Euclidean geometry. The scenario is called the twin paradox, though it is not actually a paradox. It is called a paradox because it initially appears to generate a contradiction. Special relativity says that motion is relative. If the traveling sibling is moving relative to the staying sibling, then from the traveling sibling's perspective, it is the staying sibling who is moving. Why should the asymmetry in aging apply to one twin rather than the other? If motion is relative, both twins should be able to claim that the other was the one moving, and therefore by symmetry, both should have aged the same amount. The resolution is that the situation is not actually symmetric. The traveling sibling underwent acceleration. They accelerated away from Earth, decelerated, and turned around at the distant star, and then accelerated back and decelerated on return. The staying sibling underwent none of this. Acceleration is not relative in the same way that constant velocity is relative. You can tell whether you are accelerating by feel, by the force pressing you into your seat. You cannot tell by feel whether you are moving at constant velocity, because constant velocity is genuinely relative. The asymmetry in the twin siblings' relationship. Experiences comes from the asymmetry in their histories of acceleration, not from any absolute difference in their states of motion. The physics is unambiguous. The mathematics can be worked through without great difficulty by anyone with a working knowledge of special relativity, and the result is always the same. The traveling sibling ages less. The amount by which they age less depends on how fast they traveled and for how long. At the speeds available to any current human technology, the effect is negligible. At the speeds that appear in the thought experiment, approaching a significant fraction of the speed of light, the effect is dramatic. The closer the travel speed to the speed of light, the greater the time dilation, and at speeds approaching the speed of light arbitrarily closely, the traveler could in principle return, after a subjective journey of any length, to find an arbitrarily longer time having passed on Earth. A traveler who spent 10 subjective years on a near light speed journey could return to find a century or a millennium had passed. The experimental confirmation of this is not limited to the atomic clock experiments described in the previous chapter. Subatomic particles called muons are produced when cosmic rays strike the upper atmosphere. They decay radioactively with a characteristic half-life, and based on this half-life and the height of the upper atmosphere, classical physics predicts that essentially no muons should survive to reach the ground. The muons are traveling at speeds close to the speed of light, and from our perspective on the ground, their decay processes run slowly because of relativistic time dilation. The muons experience less time between their creation and their arrival at the ground than we observe from our perspective. The predicted and measured abundance of muons at ground level is consistent with the time dilation effect and inconsistent with classical physics. The muons are aging more slowly relative to us because they are moving relative to us. What the twin scenario forces attention on is not the physics, which is settled, but the human meaning of a settled physics. The staying twin and the traveling twin are different ages. This is not a matter of perception or convention or the choice of a reference frame. It is a physical fact about how much biological time each of them has experienced. The conversation between them when the traveler returns is a conversation between two people for whom the shared childhood is equally real, but for whom the intervening period is utterly different. The staying twin has decades of context, of relationships developed and lost, of events observed and participated in, that the traveling twin does not have. The traveling twin has the journey, which is real and was experienced, but which places them outside the shared history of everyone they left. There is a specific quality of displacement that this produces, which ordinary separation does not produce. The person who goes away for 5 years and returns to find that 5 years have passed in their absence experiences a gap that is symmetrical with the gap experienced by those who stayed. The traveler aged 5 years, and so did the people at home, and the 5 years of absence is a shared fact about the period. The relativistic traveler who goes away for a subjective 5 years and returns to find 25 years have passed is not in this position. They are younger than the people who stayed, in a physical and biological sense. The world has moved on without them by a length of time they did not experience. The relationship between the twins at the reunion contains something that human relationships have not previously had to accommodate. It is not the loss of shared time in the ordinary sense of people living apart and accumulating separate experiences. It is the divergence of experienced time itself. The staying twins' present moment is later, in a deeper sense than the traveling twins' present moment. They are standing in the same room at the same moment by the calendar on the wall, and they are standing in different places in their respective lives by the measure of how much time each of them has actually experienced. There is a version of this thought experiment that extends the journey to extreme lengths. A traveler who spent 50 subjective years on a near-light-speed journey might return to find that 10,000 years had passed on Earth. Everyone they knew is long dead. The civilization they left may be unrecognizable or may be gone. The language may have changed beyond comprehension. The landmarks may be geological features. The traveler arrives in a future so distant that the connection to the past they experienced is severed not by choice or circumstance, but by physics. The twin who came back younger came back to a different world, younger in body, older in loss, having aged 5 years, inside a 25-year absence that nobody experienced. Chapter 9. The history that keeps correcting itself. There is a version of the past that you remember. It is the only version you have access to, the only version that feels real, the only version that connects to the present moment in which you are currently situated. It contains the specific sequence of events that produced you and everything around you, and it is from the inside simply the past. Not one past among many. The past, the thing that happened, which is distinct from the many things that might have happened, in the way that reality is distinct from possibility. Now introduce a thought. What if every fork in the road that the past contained, every decision that could have gone one way and went another, every quantum event that landed one way among the several ways it might have landed, every moment that was genuinely open before it was closed by what actually happened, produced not a selection between the possible outcomes, but all of them simultaneously? What if the road that was not taken was also taken, just not by you, just not in the world you continued into? What if the other outcomes are as real as the outcome you experienced, populated by versions of everything that exist in states that diverged from your world at the moment of the fork? What if there is not one history, but an enormous, perhaps infinite collection of histories, each internally consistent, each containing observers who experience it as the only history from the inside, running silently and simultaneously with all the others? This is the many worlds interpretation of quantum mechanics, proposed by Hugh Everett III in 1957 and developed by various physicists in the decades since. It is not a fringe position. It is a serious interpretation held by a significant number of working physicists, including some of the most prominent. It is also one of the most philosophically disorienting ideas that physics has produced, because it takes seriously the mathematical structure of quantum mechanics in a way that produces a result that the ordinary human relationship to reality finds genuinely difficult to accommodate. The difficulty starts with what quantum mechanics describes. The Schrödinger equation, which governs how quantum systems evolve over time, is deterministic and linear. It takes a quantum state at one moment and tells you precisely what quantum state the system will be in at the next moment. No randomness, no ambiguity. The evolution is exactly specified. The problem arises when you try to describe what happens when a quantum system is measured. Before measurement, the system exists in a superposition of multiple possible states. After measurement, it appears to be in one specific state. The equation does not tell you which state. It only tells you the probability of each possible outcome. The standard interpretation, the Copenhagen interpretation, handles this by positing that measurement causes the wave function to collapse from the superposition into one specific outcome. The randomness is fundamental. The outcome was not determined before the measurement. This is where the famous indeterminacy of quantum mechanics lives. But the collapse is not described by the Schrödinger equation. It is an additional postulate, added to account for what we observe happening without being derived from the fundamental dynamics. Everett's proposal was to take the Schrödinger equation seriously and drop the collapse postulate. If the equation says the system evolves deterministically into a superposition, then that is what happens, all the time, for every quantum system, including the measuring apparatus, including the scientists doing the measuring, including everything in the environment that interacts with the system. What we observe as a single definite outcome is what it feels like from the inside to be a component of a much larger quantum system that has evolved into a superposition of all the possible outcomes simultaneously. The branch of the wave function in which the measurement gave result A continues to evolve alongside the branch in which it gave result B, and they do not interact with each other in any way that allows observers in either branch to observe the other. From inside either branch, the other branch is inaccessible. The observer in branch A experiences result A as the definite outcome. The observer in branch B experiences result B. Both are real, both are right. They are simply in different branches of the wave function. For time travel, the many worlds interpretation offers something that the fixed timeline interpretation does not. It offers a mechanism by which the past can be changed without producing a contradiction. The time traveler who goes back and kills their grandfather does not produce a paradox, because the universe in which they make the killing and the universe in which they were born from the living grandfather are different branches of the wave function. The traveler does not return to their own past. They enter a branching universe where the grandfather dies, producing a history that diverges from their own at the moment of the arrival and the killing. Their home universe, the one in which they were born and from which they traveled, continues to exist in its branch, with the grandfather alive, with the traveler having departed. The paradox cannot form because the causal chain is never circular. The traveler is the immigrant from one branch to another, rather than an inhabitant of a circular causal loop. The many worlds interpretation also produces a specific and strange picture of what a time machine does. The machine is not a device for revisiting one's own past. It is a device for jumping from one branch of the wave function to another, specifically to branches in which the target time has not yet passed. The traveler who arrives in what they take to be the past of their own world is actually in the past of a different world, one that is similar to their own in all respects up to the moment of arrival, and that diverges thereafter. They bring their mass and their memories and their intentions from their branch into the new branch, and from that moment, the new branch is theirs to inhabit and influence. The branch they came from continues without them, populated by whatever versions of events occurred in their absence. The accumulation of branches that this produces across all of history and across all the quantum events that have ever occurred in the history of the universe is a number so large that any word applied to it understates the case. Every radioactive decay that could have occurred or not occurred, every quantum interaction, in every particle in every atom, in every object in the universe, across all 14 billion years of its history, every thought in every brain that depended on quantum processes in the neurons that generated it. The branching structure of the many worlds interpretation is a proliferation of realities on a scale that the imagination genuinely cannot encompass. What you remember as the past is the branch you are in. It is one branch, it is real, it is yours, but it is one path through a structure that contains all the paths simultaneously, most of which you will never have access to. Most of which contain people who are in some sense continuous with you, who made the same decisions you made up to some point of divergence, who then found themselves in a world that went differently. The history that keeps correcting itself is not correcting anything from outside, it is simply branching. Every time a fork appears, without choosing between the branches, taking all of them, simultaneously, silently, everywhere. Chapter 10. The moment you can never return to. There is an afternoon that exists only in memory now. Not an extraordinary afternoon, not one that was marked at the time as significant or worth preserving with any particular care. An ordinary afternoon in a specific season, with specific quality of light and a specific temperature and the specific texture of being in a place with people who are no longer available to be with in that way. The conversation was about nothing that mattered. The laughter was about something small. The particular arrangement of those people in that place at that time was not recognized, while it was occurring, as something that would not recur. It was simply an afternoon. And then it was over, and time moved forward, and the people changed or departed or died. And the afternoon became a thing that was and is no longer and will not be again. This is not a paradox in the physicist sense. The physics of the situation is not especially complex. The afternoon was a configuration of matter and energy that existed at a particular time in a particular place, and time moved forward as time does, and the configuration dissolved into subsequent configurations, as all configurations do. The physics does not have anything special to say about why the loss of this afternoon is experienced as loss, or why the word loss seems right when it is applied to something that simply ended rather than being taken. The physics knows nothing about the difference between an afternoon ending and an afternoon being lost. But you know the difference. The difference is felt. And the feeling is not explained by the physics, even when the physics is completely understood. The philosopher J.M.E. McTaggart made a distinction in 1908 that has remained one of the more useful tools for thinking about time and its experience. He called them the A series and the B series of time. The B series is the series of moments ordered by the relations of before and after. Event X is before event Y. Event Y is before event Z. This ordering is fixed and permanent. It does not change. The afternoon in memory is before the present moment, and it was always before the present moment, and it always will have been before the present moment. The before and after relations between moments are, on the B series account, as permanent and unchanging as the mathematical relations between numbers. The afternoon is not gone in the B series sense. It is simply located at a different coordinate in the four-dimensional structure of space-time than the present moment is located. The A series is different. It is the series of moments ordered by the relations of past, present, and future. The afternoon was future, then present, then past. These properties change. What was future becomes present, and what was present becomes past. And the becoming is the experienced flow of time that the B series does not capture. The A series is where the loss lives. The afternoon is in the past. It used to be in the present. It will never be in the present again. These facts are not facts about its location in a four-dimensional structure. They are facts about its relationship to now, to the moving present moment, to the here that experiences the there and then of every moment that is no longer now. McTaggart himself argued that the A series is more fundamental to what time actually is than the B series, because the B series alone does not capture the passage of time, only the ordering of it. But he also argued that the A series generates contradictions, because every moment must be past, present, and future, which are mutually exclusive properties, even though they are applied to the same moment at different times. Whether this argument succeeds or fails is still debated. What it points to is the genuine difficulty of capturing in language what the experience of time is like, and why the physics of time, which operates comfortably in B series terms, has trouble accounting for the A series experience of passage and loss. Grief is, among other things, a relationship with the irreversibility of time. The person who is gone is in the past, not inaccessible in the way that a distant place is inaccessible, where the inaccessibility is a function of distance and can in principle be overcome by sufficient effort. Inaccessible in a way that is absolute and unconditional and permanent. The structure of time, as it is experienced from inside it, does not allow for the recovery of what is past. The afternoon cannot be revisited, the person cannot be returned to. The specific configuration of the world that included them is in a position that the present moment cannot reach, not because it is too far away, but because it is in the wrong direction. Regret is a specific relationship with past moments that feel like they could have been otherwise, the decision made differently, the word not spoken, the presence not fully inhabited while it was available to be inhabited. Regret carries within it the counterfactual, the sense that things might have been different if the choice had been different. And the counterfactual is painful, precisely because the past is fixed in a way that makes the difference impossible. You can see the fork in the road. You can see where the other path would have gone. You cannot go back to the fork and take it. The regret is real. Its object is permanently inaccessible. The painful combination of the realness of the regret and the inaccessibility of its object is what makes regret different from other forms of dissatisfaction. Longing is the desire for what the present moment does not contain, and when what it does not contain is something that the past did contain, longing has the specific quality of temporal directionality. Not desire for something not yet here, which is anticipation. Desire for something that was here and is no longer here and cannot be here again, which is a form of grief by another name. The longing for a person, for a place, for a time of life that has ended, for the specific texture of a period that cannot be recovered, is the human experience of time's arrow felt as a wound. The arrow points one way. What it has passed through cannot be passed through again in the same direction. The time travel thought experiment, in all its forms, is partly a response to this. The possibility of returning to the past is the possibility of undoing irreversibility, of revisiting the afternoon, of returning to the fork in the road, of being present with the person again before the absence that followed became permanent. The interest in time travel, the pull that the idea exercises on the imagination, is not primarily an interest in physics. It is an interest in the reversal of loss, in the possibility that what time has taken is not permanently gone, that the river can be navigated upstream, that the afternoon is still there, in the past, waiting for the visit that the physics of the present moment cannot provide. The physics does not allow the visit, not with any confidence, not with any mechanism that has been demonstrated to work. The past is where it is, which is not somewhere that the present can reach. The configurations that produce the afternoon dissolved and reconfigured into the configurations that produce subsequent moments, and eventually produce this one. And the afternoon is not stored anywhere. It is not preserved in any retrievable form. It happened and then it was over, and the being over is as permanent as any physical fact can be. What remains is memory, not the afternoon, but the representation of the afternoon in a mind that was present during it. Not the people, but the representations of the people in a mind that encountered them and was changed by the encounter. The memory is not the thing, but it is the only access to the thing that the present moment has. The moment you can never return to is where you are always partly living, in the afternoons that were, that the present keeps losing, more completely, as time continues, in the direction it has always been going. Chapter 11. The Message with No Sender. There is a melody that a composer woke up knowing. Not a melody they had been working on. Not a fragment they had encountered before and forgotten and then recovered from memory. A complete and fully formed melody that was simply present in their mind when they surfaced from sleep, as though it had been placed there during the night by something that understood what it was doing. The composer wrote it down before it could fade. It became one of the most recognized pieces of music in history. Paul McCartney's account of the origin of Yesterday is a version of this story. The dream melody that was fully formed on waking. The anxiety that it must have come from somewhere and was actually someone else's composition. The checking with friends who confirmed they had never heard it before. The melody arrived. Its origin was a mystery. This is an ordinary mystery in the context of creative work. The mind does things while sleeping. It processes and synthesizes and produces outputs whose origins are not directly accessible to conscious recollection. The melody came from somewhere inside the composer's mind, built from the musical vocabulary they had absorbed across years of listening and playing, assembled in a way that felt like reception, because the assembly process was not consciously directed. The mystery is real, but its resolution, while not available in detail, is available in outline. The mind made it. Now introduce the time loop. The composer wakes up knowing the melody. They write it down. The piece of music becomes famous. A time traveler encounters the famous piece in the future, travels to the past, finds the composer the night before they woke up with the melody, and hums it to them while they sleep. The composer's sleeping mind absorbs the melody. They wake knowing it. They write it down. It becomes famous. The time traveler encounters it and travels back to hum it. The melody has no composer. Not in the sense that nobody wrote it down, because the composer wrote it down. Not in the sense that nobody performed it, because the time traveler hummed it. But in the sense that nobody created it. Nobody sat down and worked out which notes should follow which other notes, making the choices that generate an original composition. The melody arrived in the loop already complete. It entered the loop at the moment the time traveler hummed it to the sleeping composer. But where did the time traveler learn it? From the famous recording of the piece. And where did that recording come from? From the composer who wrote it down after waking with it in their mind. And where did the composer learn it? From the time traveler who hummed it while they slept. The melody has a precise and specific content. It is not random noise. It is a particular sequence of notes in a particular rhythm with a particular harmonic character. This content exists. It is real. It can be written down, performed, recorded, transmitted. It has the full ontological status of any piece of information, and it has no origin. It was not created by any mind working from first principles to generate a new sequence of sounds. It arrived in the loop already possessing whatever properties it possesses, properties that no choosing process selected, and no generative process assembled. This is the information version of the Bootstrap Paradox, and it is in some ways the most philosophically concentrated version of the problem. The physical version, in which an object loops through time without origin, is strange but at least concerns matter that has the kind of brute existence that matter always has. Matter simply is. It does not need to be about anything. It does not encode meaning. It does not have the property of representing something beyond itself. Information is different. Information has content. It is about something. It possesses a property, the property of representing a specific state of affairs that cannot be reduced to its physical substrate. The melody is not just a sequence of air pressure variations or a pattern of marks on paper. It is a musical idea with a specific character that is recognizable across different substrates and different performances. And this musical idea, with its specific and irreducible character, came from nowhere. The physicist John Wheeler used a related thought experiment to illustrate what he called the participatory universe. He imagined a game in which a person leaves a room. The other people in the room agree to answer questions as though a specific word had been chosen, but without choosing any word in advance. And the questioner returns and attempts to guess the chosen word by asking yes or no questions. Each answer is consistent with some words and inconsistent with others, and the questioner accumulates constraints until a single word is consistent with all the answers given. The questioner then announces their guess. The people in the room, if they played by the rules, must respond with either yes or no, and the word that was in some sense chosen is determined only at this final moment, retroactively satisfying all the previous answers. Wheeler's point was about quantum mechanics and observation, but the structure of the thought experiment illuminates the message with no sender. The word was not chosen in advance, but was also not random. It was constrained by all the previous answers to be a specific word, and it became that word at the moment it was forced into specificity. The information was determined retroactively by the constraints imposed across the course of the questioning. The melody in the time loop is a more extreme version. It is determined by the constraints imposed by being recognizable, memorable, and capable of persisting through the loop. Not any melody would survive. The loop selects for the melody that can be transmitted from a sleeping composer to a recording to a time traveler who hums it accurately back to the sleeping composer. Only certain melodies have this property. The loop is, in some strange sense, a filter. What this means for the concept of authorship is troubling in a specific way. The composer is credited with creating the melody. This credit is not entirely wrong. They wrote it down, they performed it. Their name is attached to it. In every ordinary and social sense, it is their melody. But in the causal sense that usually grounds attributions of creation, the sense in which a creator is the origin of the thing they created, the attribution is empty. They did not originate the melody. They were the most recent link in a loop that has no first link. The credit is given to someone who was a crucial node in the information's persistence, but was not its source. There is a question that the Bootstrap Paradox generates that most discussions of it do not address. If the information in the loop has no external origin, does it have the properties it has arbitrarily? Is the melody what it is for no reason? Or is there a sense in which the loop itself selects for content, in which only certain pieces of information are stable attractors in the causal structure of loops, in which the message with no sender is not arbitrary, but is the message that could have no sender, the message whose properties make it loop stable, the thing that persists because it is the kind of thing that can persist in the specific structure of the loop that contains it. The message came from nowhere. It has content. The content is specific and real. Nobody created it. It is the melody that the loop could carry, which is all it needed to be. Chapter 12. The assassin sent to stop himself. There is a man who knows what he is going to do, not in the ordinary sense of having made a plan and intending to carry it out, in the specific and terrible sense of having witnessed it. He has seen the historical record. He has read the accounts and studied the evidence and arrived at the conclusion with the certainty that comes from documentation and analysis rather than from intuition or suspicion, that a man by his name, with his face, at a specific time and in a specific place, did something that produced a catastrophe. The catastrophe is real, and its consequences are still being lived by the people around him. And the man who caused it, according to everything he has been able to determine, is him. He was not there. He has not done the thing. The time in question is in his past, but he was not present at it, because he was elsewhere, or perhaps because the version of him that was present is the version he is about to become when the machine is used and the journey is made. He does not remember doing it. He is not the man who did it yet. He is the man who is about to go back to stop it. He goes back. He arrives. He makes his way to the place and the time in question, intending to prevent what the records say he did there, and then something happens. Perhaps the prevention fails because the thing was going to happen regardless of his presence. Perhaps the thing happens because of his presence, because something he does in the attempt to prevent it triggers the sequence of events that the records describe. Perhaps he discovers, arriving there, that the prevention is impossible in a deeper sense, that the configuration of events is such that his only options are to do the thing and cause the catastrophe, or to do nothing and cause a different catastrophe, or to do nothing and watch the catastrophe unfold without his participation, because it was going to unfold anyway, in which case he is not the cause at all, and the records were wrong about his role. or were right about his presence and wrong about his causation. The assassin sent to stop himself is the temporal version of a structure that appears in tragedy across literary traditions. The thing that was done to prevent the oracle from being fulfilled fulfills it. Oedipus, taken from his parents at birth to prevent him from killing his father and marrying his mother, is raised by different parents in a different city, and the very separation from his birth parents and the circumstances that separation produces lead him to kill his father at a crossroads and marry his mother in her widowhood. The attempt to escape the prophecy created the conditions in which the prophecy was realized. The temporal version has a specific and additional feature that the classical tragedy does not have. The assassin knows what the records say. He is not acting on a prophecy he might doubt or misinterpret. He has the historical documentation. The catastrophe happened. He is in it, according to the record. He goes back with this knowledge, and the question is whether the knowledge changes anything, or whether the knowledge is itself part of the causal structure that produces the outcome. This is the question of whether knowing the future can prevent it, or whether knowing the future is already incorporated into the future that was known. If the records are complete and accurate, they already include whatever he did when he went back. If he went back and successfully prevented the catastrophe, the records would show that the catastrophe did not happen, and he would not have been sent back to prevent it, and the loop is broken. The prevention of the catastrophe is only stable if the catastrophe was not prevented, because only the catastrophe motivates the prevention. The successful prevention undermines its own cause. This is the grandfather paradox in the form that relates most directly to the self-referential quality of time travel in a fixed timeline universe. The grandfather paradox involves the elimination of the traveler's own existence. The assassin paradox involves the elimination of the traveler's own mission. Both are cases in which the outcome of the intervention removes the cause of the intervention, producing a causal loop that cannot close consistently. The only consistent outcomes are either the ones in which the intervention fails and the catastrophe occurs as recorded, preserving the mission and the motivating history, or the ones in which the intervention succeeds and the catastrophe does not occur, removing the motivation for the mission and the historical records that prompted it. The many worlds resolution applies here as it applies to the grandfather paradox. The assassin who successfully prevents the catastrophe does so in a branching timeline where the catastrophe does not occur. In that branch, he was never motivated by the records of the catastrophe to travel back, because the catastrophe did not happen in that branch, but he came from a branch where it did happen. He is an immigrant from a world with the catastrophe to a world without it. The inconsistency is resolved because the mission and the outcome belong to different branches of the wave function. His home branch still has the catastrophe. The new branch does not. What this resolution costs is the satisfaction of actually having prevented the catastrophe. The catastrophe he witnessed, and the records he studied, and the consequences he is trying to undo are still real in his home branch. He has not changed them. He has created a branching world in which they did not happen, but the world he came from is unchanged. The people in his home timeline are still living with the consequences. He has, in a sense, escaped to a better version of history while leaving the worse version intact. This is not nothing. A world without the catastrophe is better than a world with it, and he has produced that world. But the people he was trying to help are not in the world he produced. They are in the world he left. The fixed timeline resolution is bleaker in a specific way. In this version, the records were right. He did cause the catastrophe. He caused it while trying to prevent it, or he caused it by his mere presence, or he caused it through a sequence of events that his arrival set in motion without his intending any of it. The attempt to escape the loop is the loop. He went back to stop himself from doing it, and in going back became the version of himself that did it. The records that sent him back describe the thing he did when he went back to prevent the thing. The information he used to make his decision was information about the decision he made when he went back to change his decision. The assassin arrives. He looks at the place where the catastrophe is about to occur. He acts, or fails to act, or acts in ways he did not intend, and the record of what he did was written before he arrived, and describes exactly what he does, which is what he was sent back to prevent, which is why he was sent back. Chapter 13. The Universe as a Block. There is a version of you that is 7 years old, not a memory of a version of you, not a representation stored in neural tissue that approximates something that once was. A version of you that is 7 years old, sitting in a specific place, experiencing a specific moment, fully present and fully real in every sense that the phrase fully real can mean. This version is not waiting in some anteroom of time for its turn to be current. It is current. It is happening. The 7-year-old version of you is as real as the version reading this right now, in the same sense and to the same degree, because both of them exist in the 4-dimensional structure of spacetime. And the 4-dimensional structure of spacetime does not have a preferred moment that is more real than the others. Every moment that exists equally. The present moment is not specially actual, it is simply the moment that you are in. This is the block universe theory, and it follows with surprising directness from the physics of special relativity. The relativity of simultaneity is the feature of special relativity that makes the block universe almost unavoidable for physicists who think carefully about what the theory implies. Two events that are simultaneous for one observer are not simultaneous for an observer in relative motion with respect to the first. Whether two events occur at the same time is not a fact about the events, it is a fact about the relationship between the events and the observer. Different observers, moving relative to each other, will make different but equally valid claims about which events are simultaneous. There is no preferred frame of reference from which the true simultaneity can be established, because the theory says there is no preferred frame of reference. What this means for the concept of the present is significant and disturbing. If simultaneity is relative, then the set of events that are happening now, the events that share the present moment with you, is not a fixed and objective fact about the world. It depends on your state of motion. A different observer, moving relative to you, would identify a different set of events as constituting their present moment. Their present moment is as valid as yours. There is no way to say which of you has identified the true present moment, because the question assumes there is a true present moment that both of you are measuring, when in fact the present moment is defined relative to each observer's frame of reference. If there is no absolute present, there is no absolute now. If there is no absolute now, there is no privileged dividing line between the past and the future, because the past and the future are defined as what came before and what comes after the present, and the present is not an objective feature of reality. What there is instead is a 4-dimensional structure in which all moments exist, and in which different observers slice the structure differently when they identify their own present. The structure itself, the block, is permanent and complete. The slicing is what produces the experience of a present moment, and the slicing differs between observers. The philosopher Hermann Weyl described the human experience of time in the block universe with a sentence that has been quoted in many subsequent discussions of the topic. The objective world simply is. It does not happen. Only to the gaze of my consciousness, crawling upward along the lifeline of my body, does a section of this world come to life as a fleeting image in space which continuously changes in time. The block exists. It does not change. The experience of change and passage is the perspective of a consciousness moving through the block, encountering different moments sequentially in the way that a finger moving along a line encounters different points sequentially, without any of the points being more real than the others. The implications for questions about the past are specific. The past does not exist only as memory or record. The past exists as actual events, located at coordinates in the 4-dimensional structure. The moment of your 7th birthday is there. It is as actual as this moment. The people who are present at it, including the 7-year-old version of you, are there, experiencing it as real as any experience can be. Death does not remove a person from the block. It removes them from the subsequent coordinates. They continue to exist at the coordinates they occupied during life. The dead are not gone from existence. They are gone from the part of existence that shares the present coordinate with the living. But they are in the block, at their coordinates, as actual as anything can be. This is not a consolation in the ordinary sense. The person who is grieving does not have access to the coordinates where the person they lost exists. The block is complete, but it is not navigable in the way that a physical space is navigable. You cannot go to the coordinates where your 7-year-old self is sitting. You cannot visit the coordinates where the person you are grieving continues to exist. The block's completeness is a metaphysical fact, not a practical resource. The coordinates are real, but they are not reachable from here, by any means that the present-day physics describes as available. What the block universe does for the question of time travel is interesting. In the block, time travel would be a matter of reaching coordinates other than the ones you currently occupy. The traveler would be moving through the 4-dimensional structure rather than through the 3-dimensional spatial structure. The physics of general relativity does permit, in certain theoretical configurations of spacetime, something called closed time-like curves, which are paths through space-time that loop back to their starting point. A traveler following a closed time-like curve would return to coordinates they had previously occupied, which in the block universe language means visiting an earlier part of the block. The block already contains their visit. The visit is already there, at its coordinates. The traveler arriving is not changing anything. They are being placed at the coordinates where they were always located. The block universe therefore naturally supports the fixed timeline interpretation of time travel. The block is complete, and its content is fixed. Every event in the block is what it is at its coordinates, and will always have been what it was. The time traveler who visits the past is not altering the block. They are an element of the block, at the coordinates they occupy, which include the coordinates of their visit to the past. The visit was always in the block. The causal structure that led to the visit was always in the block. The consequences of the visit were always in the block. The traveler is not a visitor to a past that exists independently of their visit. They are part of the past, at the relevant coordinates, having always been there. There is something that sits uneasily about the block universe and the experience of consciousness. In the block, all moments exist simultaneously in the sense that they all occupy their coordinates in the four-dimensional structure. But consciousness does not experience all moments simultaneously. It experiences one moment and then another, in sequence. The movement of consciousness through the block, the crawling upward along the lifeline that Wilde described, is not something the block itself explains. The block is static. The experience of time passing is dynamic. The theory describes a structure in which change does not occur, and the task of explaining why everything feels like it is changing is left to the theory as a problem it has not yet solved. You are in the block. The 7-year-old version of you is in the block. The version of you that has not yet existed is in the block. All equally real, all equally present, in a structure that does not pass, only seems to. Chapter 14, The Machine at the End of History. There is an argument that is simple enough to state in a few sentences, and that has not been satisfactorily answered in the decades since it was first clearly articulated. If time travel to the past is physically possible, and if any civilization anywhere in the future develops the technology to do it, then the past would be populated by visitors from the future. Not necessarily visibly or dramatically. Not necessarily in ways that would be immediately obvious to people living in the past, but present, in some form, in some number, making their way through time periods that interested them, for whatever reasons future time travelers would have for choosing specific destinations. The past would contain us looking back. We are in the past. Relative to any future time traveler, we are the past they might visit. And the observation is that we do not see them. There is no confirmed, documented, independently verified instance of a visitor from the future. No artifact that demonstrably originated in a technology that does not yet exist. No communication that contained information whose accuracy could only be explained by foreknowledge. No physical evidence of a presence that the conventional history of the period cannot account for. The visitors, if they exist, are remarkably well concealed, or remarkably uninterested in leaving traces, or remarkably absent. Stephen Hawking made this argument in a form he called the chronology protection conjecture, and he made it with a lightness that contained a genuine point. The best evidence we have that time travel is not possible, or that it is not possible in the form that would permit visits to the present period, is the absence of tourists from the future. He noted that history does not seem to be crawling with time travelers, and that this observation, while not a proof, is at least consistent with the physics suggesting that the past is protected from future intervention in some way that does not yet have a satisfying theoretical explanation. The responses to this argument are multiple and worth considering carefully, because each of them reveals something about the structure of the problem. The first response is that time travelers do not visit the present because the machine has not been invented yet, and once it is invented, there will be visits. The difficulty with this response is that it assumes time travel will be invented at some specific future moment, and that travelers can only go as far back as that moment. If the machine is invented in the year 2150, then no one can travel back before 2150. We are before 2150, if that is the relevant date, and so we are in a period that the machine cannot reach. This is a coherent response, but it relocates the problem. It implies that the first moment the machine is activated is a moment that will be permanently crowded with visitors from all subsequent periods, because every future traveler will be able to reach that first moment, but no moment before it. The first operational moment of the first time machine would be the most visited moment in the history of the universe, populated by tourists from every subsequent century. That first moment also, presumably, would be detectable. The second response is that time travelers are here, but they are concealing themselves. They are visitors who have been instructed not to interfere, who observe from a careful distance and leave no traces, who blend into the periods they visit without revealing their origins. This response is logically consistent, but it requires an explanation of why every time traveler across all of future history maintains this concealment with perfect discipline. Human beings are not notably good at collective concealment over long periods. A tourism industry, even a regulated one, tends to produce deviations from the regulations. The proposed concealment would have to be essentially total and essentially permanent to account for the complete absence of confirmed traces. This is not impossible, but it requires a coordination and a discipline that the documented history of human institutions does not support as plausible. The third response is that the past is unreachable, not because of any law of physics that has been identified, but because of some effect that has not yet been theoretically described. The chronology protection conjecture itself is in this category. The conjecture proposes that the laws of physics conspire to prevent the formation of closed time-like curves, the space-time structures that would permit travel to the past, but the mechanism of the protection is not yet fully specified. Various proposals have been made, including the suggestion that quantum effects at the boundary of a would-be time machine would produce radiation intense enough to destroy the machine before it could be used. But these proposals are not yet fully worked out and are contested among physicists who work on these questions. The fourth response is that time travel to the past is possible, but the universe that the traveler visits is not the universe they came from. They go back in time and find themselves in a branching timeline. The absence of visitors from the future in our timeline is consistent with this interpretation, because the visitors are in other timelines, ones that branched off from ours when they arrived. They are not here because their arrival produced a branch that is not this branch. The absence of visitors is compatible with time travel being possible in the many-world sense, because the visitors are elsewhere in the wave function rather than in our branch. The fifth response is that time travel will never be developed, not because it is physically impossible in principle, but because no civilization survives long enough and develops sufficiently to produce the technology. The Fermi paradox for extraterrestrial intelligence and the absence of time travelers might have a common explanation in what has been called the Great Filter, some barrier that prevents civilizations from reaching the stage of development where they could produce either interstellar travel or time travel. On this account, the absence of visitors is not evidence against the possibility of time travel. It is evidence about the trajectory of technological civilizations, which apparently do not reach the relevant level of capability, or do not survive long enough to reach it, at a rate that would produce detectable visitors. The sixth response, which is perhaps the most philosophically interesting and the most difficult to dismiss, is that we would not recognize a time traveler even if one were present. Our tools for detecting the presence of technologically advanced visitors are calibrated to what we know and expect. An entity from the far future visiting our period might be as invisible to our detection methods as a person is invisible to a bacterium, not concealed, simply operating at a level of technology and sophistication that our current instruments and conceptual frameworks cannot identify as what it is. The absence from our records might be the absence of the record-keeping tools capable of making the relevant records, rather than the absence of the thing the records would record. The machine at the end of history would be the most consequential artifact ever constructed. Its invention would populate the entire past with its consequences. We are in the past. We do not see the consequences, and the explanation for the absence is itself a question that the absence has not answered. Chapter 15. The age you keep returning to. There is an age that certain people live at, alongside the age they actually are, not instead of their actual age. Alongside it, the body is 43, and the mortgage exists, and the meetings happen, and the ordinary adult life proceeds in the ordinary adult way. And somewhere underneath or beside all of this, there is also 11, or 16, or 22, or whatever the age was when something happened that the mind has not fully finished with. Not consciously dwelling on, not necessarily thinking about with any regularity, but present in the way that a tone can be present in a piece of music without being the melody, shaping the quality of the experience without being its apparent content. The age does not go away. The person keeps returning to it without always knowing they have returned, because returning to it is simply what happens when certain conditions occur. certain triggers fire, certain qualities of experience arise that rhyme with what was happening at the age in question. The psychologist's term for this is trauma, in its broadest sense, which extends well beyond the clinical presentations that the word usually evokes. Not every significant age is the age of a trauma in the clinical sense. Some people return to ages of great joy, as well as great pain, or to ages of transition that were not clearly one or the other, but that contained something unfinished, some thread that was not completed, some question that was asked by the experience and not fully answered by anything that came after. The return is the mind's attempt to answer the question or complete the thread, which is why it keeps happening. The question keeps being posed because it keeps being unanswered. The loop runs because the loop has not been closed. Freud called it repetition compulsion, the tendency to recreate the conditions of unresolved early experiences, to find them again in adult relationships and situations, to be drawn toward the configurations that match the internal template, even when those configurations are painful. The person who grew up with an emotionally unavailable parent finds partners who are emotionally unavailable, not because they want to be disappointed or because they do not recognize the pattern, because the pattern is familiar in the specific sense that familiarity and safety are linked in the emotional architecture built in childhood, and the familiar is reached for not with the mind that knows better, but with the body that knows what it has always known. The age keeps finding its way back into the present, because the present keeps finding its way back to the age. The neurobiological account of this provides a mechanism that Freud did not have access to, but that is consistent with what he observed, particularly trauma, that occurs during periods of significant neurological development, alters the structure and function of the brain in ways that affect how subsequent experience is processed. The amygdala, the brain structure most centrally involved in the processing of threat and the storage of emotionally significant memories, encodes traumatic memories in a way that makes them differently accessible than ordinary memories. Ordinary memories are located in time in a way that makes them feel like the past. Traumatic memories have a quality of presence, of nowness, that ordinary memories do not have. When they are activated, the experience is not the experience of remembering, it is the experience of being there. This is not metaphorical. The activation of traumatic memory produces physiological responses that mirror the responses of the original experience. The heart rate changes, the breathing pattern changes, the hormonal landscape changes. The body is responding to the past as though it is present, because in the architecture of the traumatized nervous system, the past is present in a way that it is not for ordinary memories. The loop runs at the biological level, not only at the psychological level. The age keeps returning because the nervous system keeps treating the events of that age as current, as still happening, as requiring the same responses that were required when they actually occurred. The philosopher and trauma researcher Bessel van der Kolk spent decades working on this and summarized his findings in a phrase that became a book title and that captures the essential point with unusual compression. The body keeps the score, not the mind, not the narrative self that can choose to think about other things. The body, which does not have access to the narrative self's editorial choices, which processes experience at a level below the conscious construction of the story about what is happening, which stores the response to significant experience in ways that the conscious narrative does not control. The loop runs in the body before it runs in the mind, and interrupting it requires working with the body in ways that working only with the narrative mind does not. The temporal quality of the traumatic loop is what makes it specifically relevant to a series about time travel. The person in the grip of a traumatic activation is not, in the experiential sense, entirely in the present. They are partly in the past, partly at the age, partly in the experience that the current trigger has activated. Two temporal locations at once, the body in the present, responding to present stimuli in ways shaped by past experience, while the nervous system processes those present stimuli through the template of the past experience, producing an experience that is located in neither time cleanly, but in both simultaneously. The loop is not theoretical, it is lived. It is the daily experience of a significant proportion of the population. Nostalgia is the gentler version of the same structure. The return to an age that was pleasant rather than painful, or that is remembered as pleasant, even if it was not entirely so, or that has acquired the quality of pleasantness through the specific filtering that memory performs on the past. The age of adolescence that felt confusing and painful while it was occurring becomes 30 years later a time of vivid feeling and clear purpose that the adult life seems to lack. The return to that age through memory is a return that the memory makes available, rather than the past itself. But the availability is real, and the quality of the experience of returning is genuine. The person who feels nostalgic is genuinely in contact with something, not the past itself, the representation of the past in a mind that has been living for years without whatever the past contained. Proust spent approximately 1.5 million words describing the operation of involuntary memory, the mechanism by which a taste, or a smell, or a quality of light can transport a person to a specific moment in the past, with a vividness that voluntary recall cannot achieve. The Madeleine dipped in tea, the return to Cambrai. The involuntary memory does not place the person in the past, as a time traveler is placed there. It places the past in the person, makes a section of it present in the current moment, with a fullness that the voluntary reconstruction of it from narrative materials cannot match. Proust's project was partly the attempt to understand what was happening when this occurred, and to replicate it, to find a way to hold the past present that did not depend on the accident of the right trigger firing at the right moment. The loop that the psychological time travel creates is different from the loop of the causal paradox. It can be broken, not easily, not without effort, not by simply deciding to break it. But the mechanisms of breaking it exist and have been documented, and some of them work for some people in some circumstances. The traumatic loop can be interrupted by approaches that engage the body rather than only the narrative. The nostalgic loop can be interrupted by the recognition that what is being sought in the past is actually a quality of presence and aliveness that is available in the present if the conditions for it can be created. The age you keep returning to is keeping you company. It is also keeping you from somewhere. The somewhere is not the future, it is the present, which the return to the past has been filling, in the place where the present could be. Chapter 16. The Butterfly That Ended Civilization. There is a story by Ray Bradbury published in 1952 called A Sound of Thunder. A hunter travels back in time 66 million years to shoot a Tyrannosaurus that was already going to die moments later, minimizing the causal interference of the visit. He is told to stay on the designated path. He steps off it. He kills a butterfly. He returns to his present and finds it changed in ways that are initially subtle and then unmistakably catastrophic. The language has shifted slightly. The social order has changed. A different person won an election. The death of a butterfly 66 million years ago was the beginning of a causal chain that produced a different civilization than the one the hunter departed from. The butterfly was a hinge on which history turned, and the hunter stepped on it. The story gave the name to a concept that was being developed independently around the same time in the mathematics of dynamical systems. The concept is sensitive dependence on initial conditions, and it describes the behavior of certain kinds of systems, including weather, certain ecological systems, certain fluid dynamics, and in principle, the entire physical evolution of the universe. In these systems, small differences in the initial state produce large differences in subsequent states, and the differences grow exponentially with time, so that after a sufficient period, states that began arbitrarily close together are arbitrarily far apart. The butterfly in Bradbury's story is a specific literary instance of a mathematical reality. Edward Lorenz, the meteorologist who was most associated with the formalization of this idea, discovered it accidentally in the early 1960s while running weather prediction simulations on a primitive computer. He ran a simulation, stopped it, and then restarted it from a point partway through, entering the values from the printout manually. The simulation, restarted from what he believed were the same initial conditions, produced a drastically different result. The explanation was that the printout showed values rounded to 3 decimal places, while the computer was computing with 6 decimal places. The difference between the printed value and the actual value was less than 1 part in 1,000. After a sufficient simulated time, this tiny difference had produced a completely different weather system. Lorenz presented this finding in a 1972 paper whose title has become one of the most famous in the history of science. Predictability: Does the flap of a butterfly's wings in Brazil set off a tornado in Texas? The question was rhetorical and was intended to illustrate the point about sensitive dependence rather than to claim that there was a specific butterfly responsible for a specific tornado. The sensitivity is a feature of the class of systems, not a claim about any individual causal chain. But the title captured something that the mathematics had revealed. For certain kinds of systems, including the atmosphere, The differences between possible futures are so sensitive to the precise details of the present state that any uncertainty in the initial conditions produces complete uncertainty in the prediction after a sufficiently long time. The implications for time travel are specific and sobering. If the atmosphere, and through the atmosphere the ecology, and through the ecology the biological and eventually the social history of the planet, is a system with sensitive dependence on initial conditions, then any intervention in the past, however careful and however small, produces a future that diverges from the original with a speed that grows exponentially. The careful time traveler who goes back and observes from a safe distance disturbs the air by their presence. The disturbed air is the beginning of a causal chain. The causal chain amplifies. The future that results is not the future that sent the traveler. This creates a problem for any version of time travel that is designed to produce a specific result. The traveler who goes back to prevent the catastrophe is intervening in a system with sensitive dependence on initial conditions. The intervention produces a future, but the future it produces is not predictably the future that was intended. Small differences in the execution of the intervention, in the exact time and place and manner of the action taken, will produce large differences in the resulting history. The catastrophe might be prevented. A different catastrophe might occur. The civilization might be improved, or it might be destroyed. The feedback between the intervention and the system it is intervening in is not controllable in the way that the traveler's intentions require. The practical implication of this for time travel design is that the traveler cannot reliably produce the future they want by intervening in the past. They can produce a future, but the specific future is not in their control because the system they are producing it in is chaotic. The chaos is not a failure of the time traveler's skill or planning. It is a feature of the kind of system the world is. The butterfly problem is not a problem about butterflies. It is a problem about the mathematical structure of the world's evolution through time. There is a specific relationship between the butterfly effect and the grandfather paradox that is worth examining. The grandfather paradox arises when the time traveler makes an intervention that prevents their own existence. The butterfly effect suggests that almost any intervention in the past is capable of producing a future significantly different from the one the traveler came from, simply through the amplification of small differences. If the intervention changes the future enough, it might produce a future in which the traveler was not born, not because the intervention was specifically aimed at their ancestors, but because the changed history produced a different sequence of encounters and conceptions and circumstances that resulted in different people being born. The grandfather paradox is not just a special case involving deliberate interference with the causal chain leading to the traveler. It is a special case of the general principle that significant interventions in a chaotic system can produce futures arbitrarily different from the starting point. The traveler who goes back carefully, who tries to observe without intervening, who stays on the designated path and touches nothing, is still disturbing the air. The photons bouncing off their surface are interacting with matter that would otherwise not have interacted with those photons. The heat from their body is affecting the temperature of the air around them. The sound of their breathing is generating pressure waves in the atmosphere. Each of these is a perturbation of the initial conditions. Each of these will amplify. In a system with sensitive dependence on initial conditions, the careful observer and the careless intervener are distinguished by the magnitude of their perturbation, not by whether they perturb. The perturbation is unavoidable. The amplification is a feature of the system. The future that results is not the future that was. There is a version of this that is not about time travel at all, but about ordinary life. The choices that feel small, and the encounters that seem coincidental, and the moments that appear unremarkable, are all perturbations in a chaotic system. The person you did not sit next to on the train, the conversation that did not happen, the introduction that was not made, the history that did not occur because the small thing went differently, the butterfly that was never stepped on, whose life produced a causal chain that led here, to this moment, this specific configuration of the world that is reading about a story written 70 years ago about a hunter who stepped off a path. The butterfly that ended civilization was not trying to end anything. It was just flying, in the direction the air was moving. Chapter 17. The God Problem of Time Travel. There is a thought experiment that begins simply enough and then refuses to end. A person travels back in time and through a sequence of actions creates the conditions that make their own birth possible. They introduce their grandparents to each other. Or they deliver the scientific knowledge that made the civilization that made the time machine possible. Or they provide the initial inspiration the seed idea, the thing that started the process that eventually produced the person who went back to start the process. They are their own ancestor in a causal sense that goes beyond the biological. They are the origin of the chain that produced them. The chain is complete. It is internally consistent, and it has no beginning. This is the temporal version of a question that theology has been asking for a very long time. If everything that exists was caused by something that came before it, what caused the first thing? The infinite regress of causes, each one requiring a prior cause, seems to demand either an infinite chain with no beginning or a first cause that was not itself caused, a thing that simply was without having been made. The time travel version generates the same structure, but in a finite loop, rather than an infinite chain. Instead of an endless regress of prior causes, there is a circle of causes with no external origin. The person was caused by the journey was caused by the time machine was caused by the civilization was caused by the person who went back. The circle is closed, the origin is nowhere. Aristotle's response to the infinite regress of causes was the unmoved mover, something that caused everything else without itself being caused. The first cause that had no prior cause, the origin of the causal chain that was not itself an effect of anything preceding it. This unmoved mover was a logical necessity in Aristotle's framework, required to stop the regress from going on forever. Many subsequent thinkers identified the unmoved mover with God, the uncaused cause, the thing that simply is, and from which everything else derives its existence. The temporal loop in time travel creates an uncaused structure without requiring an uncaused thing. The circle of causes is self-sustaining. Nothing in it was the origin. Everything in it has a cause. The origin is simply absent, replaced by the loop's self-reference. What the loop does to causality depends on what you think causality is. The standard account of causality involves a direction. Causes precede effects. The cause happens first, and the effect happens after. The causal arrow points from past to future, in the same direction as the temporal arrow discussed in the first chapter of this series. The loop bends the causal arrow into a circle. Every event is both a cause and an effect of other events in the circle, and the circle as a whole has no external cause. The causal arrow does not point from past to future in the loop. It points around. The circle of cause and effect closes on itself, and the direction of the pointing becomes the direction of travel around the circle, rather than the direction from past to future. Whether this destroys causality or merely demonstrates that causality is more complex than the simple past to future account suggests, depends on the analysis. The philosopher Michael Dummett argued that causal loops are logically coherent and do not violate any fundamental principle of causality, properly understood. The events in the loop have causes. No event occurs without a prior cause. The fact that the prior causes include events that are in the causal loop's future does not violate any law of logic. It only violates the intuition that causes must be in the past, which is an empirical generalization from ordinary experience, rather than a logical necessity. In a universe with time travel and causal loops, the empirical generalization fails to hold universally. That is a fact about the universe, not a logical contradiction. Others have argued that the causal loop is genuinely impossible, and that its impossibility is what the absence of time travelers evidenced in the previous chapter is evidence of. If loops of this kind are coherent, then the universe we live in, which does not appear to contain them, is a peculiar special case. If loops of this kind are incoherent, then the absence from our universe is explained. The chronology protection conjecture is in part a response to this. The conjecture proposes that the laws of physics prevent closed causal loops from forming, which means they prevent time travel to the past of the kind that would create such loops. The universe protects causality by preventing the structures that would violate it. The God problem of time travel is the God problem with the theology removed and the circularity made explicit. In the theology, the question is how existence originated, what the first cause was, who or what started the chain. The answer of an uncaused cause is philosophically suspicious because it appears to exempt a particular entity from the very principle whose operation it is supposed to explain. If everything requires a cause, and if God is everything, then God requires a cause. If God does not require a cause, then the principle that everything requires a cause is false, and the argument for the necessity of a first cause collapses. The uncaused cause is either inconsistent with the principle it is supposed to satisfy, or makes that principle unnecessary. The causal loop replaces the uncaused cause with a structure that has no cause external to it, but that contains only caused events internally. Every event in the loop has a cause. The loop as a whole has no cause. This avoids the inconsistency of the uncaused cause, because the loop is not a thing that requires a cause, in the same sense that an individual event requires a cause. The loop is a structure, and the question of what caused the structure is a different kind of question from the question of what caused the events within it. The events within it have answers. The structure as a whole does not, or the answer is that the structure simply is, which is the same answer that the theological unmoved mover gives for God. The question of whether causality survives this is a question about what causality is. If causality is the relation between individual events in which one event brings about another, then causality survives the loop because the individual events within the loop stand in that relation to each other. If causality is a feature of the universe's overall structure that requires a directed ordering from uncaused origins to caused effects, then the loop undermines it by creating a structure with no uncaused origins and no directed ordering. Both of these descriptions of causality have philosophical defenders, and both face difficulties. The person who went back in time and created the conditions for their own existence is not a god. They did not create themselves from nothing. They participated in a circular causal structure that produced them along with everything else in the loop. But the loop looks like creation from the outside, if outside means from the perspective of someone asking where everything in the loop came from. Because the answer is that it all came from itself, which is what creation from nothing means if you drop the nothing and replace it with a circle. Causality runs around the loop, looking for somewhere to start, finding only the next event, which was caused by the event before it, which was caused by the event before it, which was caused by the first event, which was caused by the last event, which was caused by all the events. Chapter 18. The photograph that shouldn't exist. There is a photograph in a frame on a mantelpiece. The photograph shows two people standing in front of a building that no longer exists, in clothing that dates the image to a period several decades before the people in it were born. The image is sharp. The developing quality is consistent with the technology of the period it depicts. The paper stock, if examined by a conservator, would test as being of the age suggested by the image. The photograph is, by every material criterion available, a genuine artifact of the period it depicts, and the people in it are who they appear to be. They were there. The photograph shows them there. They look younger than they currently are, by exactly the amount they should look younger if the image was taken when and where it appears to have been taken. This photograph in the time travel thought experiment was carried back in time by the people depicted in it. They traveled to the period and the location, stood in front of the building, had the photograph taken, and brought it back with them. The photograph is genuine. It is authentic. It will test as being of the age indicated, and the tests will not be wrong, because it is of that age. It was made then, by the photographic technology of that period, using the chemistry of that period, on the paper of that period. It has been aging since then, and the aging is real. The photograph is precisely what it appears to be, and also something that should not exist. It should not exist because the people in it were not born until decades after it was taken. The photograph shows people who did not yet exist at the time of its making. This is not a photograph of their ancestors who happen to look like them. It is a photograph of them at the time in question, in a past they visited by means that were not available in that past. The image is genuine, and the situation it documents is an impossibility, and both of these things are true simultaneously. The object that loops through time, never manufactured in the conventional sense, exists in a category of things that are real in every verifiable respect, and that have no coherent origin story. The photograph was made in the past. The people in it came from the future. The photograph existed before the people in it were born. The people in it existed before they went back to be photographed. The photograph and the people form a closed loop, in which each is the precondition of the other. Neither was manufactured in the conventional sense of being produced by processes that began before their production and ended after it. They simply loop. The loop contains them. The loop is their origin. The philosophical term for the status of the photograph is ontologically anomalous. It exists, but its existence violates the conditions that ordinarily explain how things come to exist. Things come to exist by being made from prior materials through processes that require causes preceding their effects. The photograph was made from prior materials through a process that required causes preceding their effects. The anomaly is not in the photograph's individual history, which is entirely ordinary. It is in the relationship between the photograph's history and the existence of the people depicted in it, which forms a loop that has no beginning. Jorge Luis Borges, who spent much of his literary career on the territory adjacent to these paradoxes, wrote a story called The Garden of Forking Paths, in which time is described as a network of diverging, converging, and parallel possibilities. He also wrote The Book of Sand, about a book with no first or last page, that cannot be held open to the same page twice, that exists without having a beginning or an end. The Book of Sand is the Bootstrap Paradox made into a physical object. It is the photograph that should not exist made into a book. It is the kind of thing that time travel loops produce, a thing that is entirely real in its physical details and that cannot have originated in the way that physical things are required to originate. The question of whether the photograph's information has an origin is the version of the bootstrap problem that applies to information rather than to objects. The photograph contains information. It is a specific pattern of light and dark areas that encodes the shapes and features of the people and the building depicted in it. This information is specific. It is not random. It encodes something real, the actual appearance of the people and the building at that moment. The encoding happened through the ordinary process of photography. Light from the scenes struck the photographic medium and produced a chemical change. The information in the photograph derives from the light from the scene. The light from the scene came from the sun reflecting off the people and the building. The information in the photograph is therefore derived from the actual state of things at the moment of the photograph. But the state of things at the moment of the photograph includes the presence of people who came from the future. Their presence is part of what the photograph records. Their features, encoded in the image, are features that did not exist in that period of history, except by virtue of their time travel. The information about their appearance that is in the photograph was derived from their actual appearance when they were photographed. Their actual appearance at that moment was the appearance they had when they traveled back from the future. The information loops. The photograph encodes information about people whose presence in the past is established by the photograph. The physicist and information theorist Seth Lloyd has thought about information in closed time-like curves and has argued that quantum mechanics permits certain kinds of information in loops that classical reasoning would prohibit. In his formulation, the loops can contain self-consistent information that does not require an external origin, in the same way that self-consistent solutions to mathematical equations exist, without requiring an external source. The information in the loop is consistent. It has a structure that satisfies the constraints imposed by the loop. It doesn't need to have come from outside the loop, because the loop's constraints are sufficient to determine its content. This is a different way of thinking about what the photograph is. Rather than thinking of it as a thing that was made by a process that had a beginning, think of it as a thing whose existence is constrained to be what it is by the structure of the loop it is in. The loop requires a photograph with specific features. The photograph has those features. The photograph's existence is explained by the loop's requirement for something with those features. The loop is the explanation. The loop does not itself require an explanation from outside the loop because it is self-consistent, in the way that a mathematical structure is self-consistent, without requiring an external explanation for why the mathematics is as it is. The photograph sits on the mantelpiece. The people depicted in it are older now, by the decades that have passed since they were photographed. The photograph was taken before they were born. They took it with them when they went. It shows them there. They were there because they went. They went because the photograph shows them there. And the photograph has been sitting in a frame long before anyone was born. Chapter 19. The feeling of déjà vu taken seriously. There is a moment that arrives without warning and is gone before it can be fully held. You are in the middle of something ordinary, a conversation in a room you have been in before, or a moment in a room you have not been in before, or somewhere in between. Somewhere whose familiarity is ambiguous in a way that the ordinariness of the moment usually prevents you from examining. And something happens to the quality of the experience, a recognition that is not recognition because there is nothing specific to recognize. A certainty of having been here that the calendar says is impossible. The conversation, the light, the angle of the table, the specific sentence being spoken, all of it feels not like something that resembles a previous experience, but like the previous experience itself, being experienced again. The present moment has already happened, not like it, already, and then it is gone. The ordinary resumes, the strange quality dissolves. You are left with the memory of a strange few seconds and the faint discomfort of having been briefly uncertain about where in time you were. The neuroscience of déjà vu is settled enough in its outlines that the phenomenon is not mysterious in the way it was for most of human history. The experience arises from a mismatch in the brain's memory processing systems. The brain processes familiarity and recollection through partially distinct neural circuits, and under certain conditions, these circuits can fire in a desynchronized way, producing the feeling of familiarity, of having encountered this before, without the accompanying recollection that would specify when or where the previous encounter occurred. The familiarity signal fires without the recollection signal that would provide its context. The present moment feels like a memory because the brain is processing it through the circuit that normally handles memories, rather than through the circuit that normally handles novel present experience. This account is sufficient to explain the experience in its ordinary form. The experience is common, affecting a significant majority of adults at some point in their lives. It tends to be more frequent in younger adults and decreases with age. It is associated with certain neurological conditions, particularly temporal lobe epilepsy, where it can occur in more intense and prolonged forms as a feature of the aura preceding a seizure. The temporal lobe is involved in the processing of memory, which is consistent with the account of déjà vu as a memory processing anomaly. The neuroscience coheres, the experience is explained. What the neuroscientific account does not engage with is the specific phenomenological content of the experience. The explanation says the experience arises from a processing error. The experience itself says that this has already happened. These are different claims about different things. The neuroscience describes the mechanism. The experience makes a claim about time. The claim that the experience makes is a claim about having been here before in a way that the ordinary explanation of repeated experience cannot account for, because the experience is explicit about its impossibility. It is not the feeling of having seen something similar. It is the feeling of having been in this specific moment, which is presently occurring for what should be the first time. Taking the experience seriously as a possible signal, rather than as a processing error, requires specifying what it might be a signal of. The time travel hypothesis is one possibility, and it has the specific virtue of fitting the content of the experience rather than explaining it away. If the present moment has already been passed through by a version of yourself from a subsequent point in the future, or if the present moment is one that has occurred in a previous cycle of a cyclical universe, or if the present moment exists in the block universe as a coordinate that consciousness has already traversed in some sense that the linear narrative of memory does not capture, then the feeling of having been here before would be, in some formulation of the relevant physics, not a processing error, but an accurate perception. The cyclical universe hypothesis, in which the universe goes through repeated cycles and the current cycle is not the first, would in principle provide a mechanism for something like genuine temporal recognition. If the events of the universe repeat, if the history replays, then the present moment has occurred before in a genuinely literal sense. The question is whether any trace of the previous cycle could persist into the current one, and most formulations of cyclic cosmology do not provide a mechanism for such persistence. The cycles are complete resets. The previous cycle is not available as memory in the current one. The neuroscientist's processing error account and the cyclical universe account would produce the same phenomenology, because neither would provide actual memories of the previous cycle. The experience would arise from the same desynchronized familiarity signal in both cases. The block universe account is subtler. In the block universe, all moments exist simultaneously in the four-dimensional structure. The present moment is not the only actual moment. The past moments and the future moments are equally real, equally present in the structure. If consciousness has any non-local relationship to the block, any access to its own existence at coordinates other than the current one, then the sense of having been here before might be a signal of the block's completeness rather than a processing error, not a memory of the previous cycle, something more like a recognition of the structure. The block contains this moment. The consciousness that inhabits the block at this moment has, in the block's terms, always been here. The feeling of having been here before might be the feeling of the block's permanence leaking through the temporal narrative. This is speculative in ways that exceed what the current science supports. The block universe is a serious scientific theory. The idea that consciousness has non-local access to the block is not, and the proposal is more philosophy than physics at this stage. It would require a theory of consciousness that goes well beyond what current neuroscience provides and that accounts for the specific way the apparent non-local access might work without violating what is known about how the brain processes information. The proposal is not impossible. It is simply far ahead of any theoretical or empirical basis that would allow it to be taken seriously as anything more than a hypothesis. What taking the experience seriously does, even if none of the specific physical accounts of what it might signal are ultimately correct, is resist the reflex of explanation as dismissal. The neuroscientific account explains the experience. It does not engage with the experience's content. The experience claims something about time. The claim might be wrong, arising from a processing error, as the neuroscience suggests. Or the processing error might be the mechanism by which a genuine signal of something about time is experienced. The mechanism of perception and the reality of what is perceived can come apart. Pain is a signal of tissue damage, even when the mechanism of pain processing is sometimes unreliable. The familiarity signal might be misfiring, and might also in some cases be firing in response to something real. The moment arrives, the certainty settles, everything is exactly as it was, a few seconds of absolute impossible recognition, and then the ordinary resumes, as if nothing happened, as if the moment was new, as it was, as it will have been. Chapter 20. The last second before death. There are accounts from people who survived what should have been fatal moments. The drowning that was interrupted by rescue, the fall that was survived against expectation, the cardiac arrest that was reversed. And among the accounts, with enough consistency to constitute a pattern, rather than a collection of isolated anecdotes, is a specific report about time. The moment of apparent dying, or the moment of extreme mortal danger, was experienced as lasting much longer than any external clock would suggest it lasted. Seconds that contained the experience of minutes, a moment of time that expanded to hold something larger than a moment should be able to hold. Not all accounts include this feature. Many do. The scientific literature on near-death experiences is larger and more rigorous than popular accounts of it tend to suggest, and the temporal distortion is among the features that has been examined with some care. The subjective sense of time expanding in moments of extreme stress or danger is a well-documented psychological phenomenon with multiple proposed mechanisms. Heightened arousal increases the density of memory encoding, so that more is encoded per unit of time, producing a retrospective sense that more time passed. Attention narrows in threatening situations in ways that change the subjective experience of duration. The emotional salience of the moment affects how it is processed and how long it seems. These are real mechanisms, and they explain something about the phenomenon without fully exhausting it. The subjective expansion of time in extreme moments is real, and is explained by memory encoding density and attentional narrowing. What these accounts sometimes describe goes further than what those mechanisms seem adequate to account for. The experience of a complete life review, the sense of having revisited the full span of one's memories in a period of time that was, by the external clock, very short. The sense not merely of more being encoded, but of more being experienced, of time having actually slowed, or of consciousness having found access to a different relationship with time than the ordinary waking state provides. The physicist and philosopher David Chalmers has written about what he calls the hard problem of consciousness, the question of why there is something it is like to be a conscious being at all, why the physical processes of the brain are accompanied by subjective experience rather than occurring in the dark without any inner witness. This problem has not been solved and is not close to being solved, and part of why it has not been solved is that the relationship between the physical processes and the subjective experience is not understood well enough to make specific predictions about edge cases. What happens to subjective experience when the physical processes that ordinarily sustain it are disrupted is an empirical question whose answer is not constrained by any current theory in the way that would allow confident prediction. The specific question of whether consciousness can experience time at a different rate than the physical processes that sustain it is a question that sits at this theoretical frontier. The ordinary assumption is that the rate of experience is tied to the rate of the underlying physical processes. If the brain slows down, experience slows down. If the brain is deprived of oxygen, experience degrades and eventually stops. This assumption follows naturally from the view that consciousness is produced by the brain, in the way that digestion is produced by the stomach, and that the rate and character of the experience tracks the rate and character of the underlying process. But the hard problem of consciousness suggests that the relationship between physical processes and experience is not well understood, and there are philosophical positions on the nature of consciousness that would permit a different relationship between physical process rates and subjective experience rates than the simple tracking assumption implies. If consciousness is not simply identical to the physical processes, but is something they give rise to through a relation that is not yet understood, the character of that relation in edge cases is not predictable from the ordinary case. The edge case of the dying brain, with its specific pattern of changing physical processes, might give rise to a specific pattern of experience that does not simply track the ordinary rate. The account that has the deepest philosophical resonance with this possibility comes not from neuroscience, but from the phenomenology of time itself. Henry Bergson, writing in the early 20th century, argued that time as it is lived, duration as it is experienced from the inside, is fundamentally different in character from time as it is measured by clocks. Clock time is spatial, divisible into uniform units, each of which is like every other. Lived duration is flowing, qualitative, not uniformly divisible, a continuous becoming that the spatial metaphor of the clock fails to capture. The rate at which clock time passes and the rate at which duration is experienced are not the same thing and are not measured by the same instrument. If Bergson is right about the difference between clock time and lived duration, then the question of whether a lifetime can unfold in a second is not a question about physics, but a question about the relationship between the two kinds of time. The second, measured by the clock, is a unit of clock time. The lifetime as experienced is a quantity of lived duration. The relationship between these two quantities is not fixed in the way that the relationship between two units of clock time is fixed. It is a relationship that varies with the state of the experiencing consciousness. In altered states, in extreme states, in the edge case of the dying consciousness, the relationship might be different from what it is in ordinary waking consciousness, different in ways that would make the experience of a lifetime in a second not a paradox, but a feature of what happens when the link between clock time and lived duration is loosened by the conditions of dying. There are accounts from people who describe elaborate and coherent experiences occurring during verified periods of cardiac arrest when the brain should not have been capable of producing coherent experience that remain unexplained by the standard accounts of how the dying brain works. Not unexplained in the sense of being beyond any future explanation, unexplained in the sense of not being accounted for by the mechanisms currently available. The standard account says that the brain deprived of oxygen loses its capacity for coherent experience within seconds. Some of the accounts describe coherent and elaborate experiences occurring during extended periods of cardiac arrest. The gap between the standard account and the reported experience is a gap that has not been closed. The last second before death is a place that the living can only approach by imagination, and that the dying have not returned from, in forms that allow reliable reporting of what was there. The people who have returned from near death are people who were near death, not past it. Whether the final second before the irreversible end is like the near-death accounts, or like ordinary dying, or like something else entirely that no one has described because no one has returned, is a question that does not have an answer accessible from this side of the question. What the question opens is the possibility that the relationship between the time measured by clocks and the time experienced by consciousness is not fixed in the way that ordinary life suggests, that there is more room in a second than a second seems to contain, that the last one might be larger than all the ones before it. Chapter 21. The Universe That Remembers. There is a glass of water sitting on a table. At some point in the past, a raindrop fell somewhere in the world and began a journey through the water cycle, through clouds and rivers and treatment systems that eventually delivered some of the molecules in this glass to this place. The raindrop that fell, the specific impact it made on a specific leaf on a specific tree, displaced air in a pattern that propagated outward in all directions as a pressure wave. The pressure wave interacted with every molecule of air it encountered, and those molecules interacted with other molecules, and the pattern spread and diminished and was absorbed into the ambient state of the atmosphere. The sound of the raindrop is gone. It cannot be heard. The memory of the raindrop exists, if it exists at all, only in the minds of any creatures that might have perceived it at the time and retained some trace of the perception. The raindrop seems to have left no record, but this is not quite accurate. Every molecule that the pressure wave interacted with was left in a slightly different state by the interaction. Each of those molecules subsequently interacted with other molecules, and those interactions were different in some small degree from what they would have been if the pressure wave had not passed through. The differences propagated forward, diminishing and diffusing, but never fully disappearing, because the evolution of a physical system is deterministic, and the information about the initial state is, in the relevant physical sense, preserved in the subsequent state. The universe is, in this sense, still vibrating from every sound that has ever been made in it. The information is present. It is just extraordinarily difficult to read. This is the principle of unitarity in quantum mechanics, and it is one of the most fundamental and most contested features of the theory. Unitarity says that quantum mechanical evolution preserves information. The evolution of a quantum state from one moment to the next is a reversible process. Given the current state of a quantum system, you can in principle reconstruct its past state exactly, because the evolution preserves all the information about what came before. The current state of the universe is, in principle, a complete record of its entire history. Everything that has ever happened has left a trace in the current configuration of everything. The universe is a memory of everything it has contained. The physicist John Wheeler, whose ideas have appeared several times in this series, expressed something adjacent to this with his concept of it from bit. The physical world, in Wheeler's vision, is fundamentally informational. The it of physical reality is constituted by bits of information, by yes or no answers to physical questions.
And the evolution of the physical world is the evolution of information.
If this is right, then the universe's conservation of information is not just a mathematical property of the equations, but a fundamental feature of what the universe is. The universe is made of information, and information, once in the universe, does not leave it. The black hole information paradox is the most acute contemporary version of the question about whether the past truly disappears. Black holes, according to the general relativity that describes them, have the property that anything falling in cannot escape. The event horizon is the boundary beyond which the escape velocity exceeds the speed of light, and since nothing travels faster than light, nothing that passes the event horizon comes back. Information about things that fall into black holes seems to be lost to the outside universe. The things fall in, the black hole eventually evaporates through Hawking radiation, and when it is gone, the information about what fell in is gone with it. Stephen Hawking proposed this and spent much of the latter part of his career debating its implications. If black holes destroy information, then unitarity is violated. The universe does not preserve all information about its history. Some information is genuinely lost.
The past, for things that fall into black holes, genuinely disappears.
The other physicists who worked on this problem mostly concluded that this could not be right, that unitarity must be preserved, that the information about things that fall into black holes must be encoded in the Hawking radiation that the black hole emits as it evaporates, in a form that is extraordinarily scrambled and practically impossible to read, but that is in principle there. The argument continued for decades and has not been fully resolved, but the consensus has shifted toward the view that information is preserved and that Hawking radiation encodes the information about what fell in. The practical implication of unitarity for the question of whether the past truly disappears is that it does not, at least not in the sense of information being lost. The past is encoded in the present state of the universe. Every event that has ever occurred has left a trace, however attenuated and however scrambled, in the current configuration of every particle that was in causal contact with it. The universe is, in this sense, a hologram of its entire history. Not a readable hologram, not a hologram from which the history can be easily reconstructed, but a hologram in the technical sense of a current state that encodes all the information about past states. For time travel, this has an interesting implication. If the past is encoded in the present, then in principle, a sufficiently powerful computation could read the present state of the universe and reconstruct any past moment from it. This is not time travel in the sense of physically sending a person or an object to a past time. It is time travel in the sense of reconstructing the past with sufficient fidelity to observe it. The obstacles are practical rather than physical in principle. The computation required would be of an order that exceeds any conceivable technology by an enormous margin. But the information is there. The past is in the present. Every moment of history is encoded in the current state of the universe, waiting for a computation powerful enough to read it. The personal version of this is the question of what happens to a consciousness when the physical processes that sustain it end. If the universe preserves information, and if a consciousness is a configuration of information, then the consciousness is, in some sense, still in the universe after the physical processes that expressed it have ended. Not in the sense that the person continues to have experiences. The experience requires the specific dynamic processes. But the information that constituted the person is still there, encoded in the state of every particle that was ever in causal contact with them, which is eventually every particle in the universe. The person, as information, is present in the universe forever. in the scrambled and practically unreadable form of everything that their existence influenced. The universe that remembers is not remembering in the way that a mind remembers. It does not have access to the stored information in the form of recollection. The information is there in the same sense that the message is there when it has been encrypted beyond any practical possibility of decryption. The message exists. It cannot be read. The past exists. It cannot be visited. The information is present. It is not accessible. But present and inaccessible is different from gone. The raindrop's impact is still in the air. The conversation that ended is still in the state of the room. The person who is no longer here is in the state of everything that they ever touched, which is eventually everything. Chapter 22. The Time Capsule as a Prayer. There is a metal cylinder buried beneath a cornerstone somewhere. It was placed there at a ceremony that involved speeches and perhaps some music, and certainly the specific mixture of solemnity and self-consciousness that public ceremonies of this kind tend to produce. Inside the cylinder are objects and documents chosen to represent the present moment to the future that will eventually open it. A newspaper, some coins, photographs of the people who were there. Perhaps a letter addressed to the person who will one day dig it up, which begins with the words, "You are reading this in a future we cannot imagine," and which then proceeds to imagine it anyway, with the specific combination of aspiration and anxiety that characterizes human attempts to speak across time. The cylinder was sealed, the ceremony ended, the cornerstone was laid on top of it, the building went up, the years passed, the people who were at the ceremony aged, and some of them died, and the world changed in ways that the letter anticipated and in ways that did not anticipate, and in ways that the letter had no framework to even gesture toward. The cylinder is still there, in the dark beneath the cornerstone, holding its cargo of the present that is now the past, addressed to a future that may or may not arrive in any form that would make the opening of the cylinder meaningful. The time capsule is one of the oldest human practices that exists in something close to its current form. The Egyptians sealed objects in tombs with an explicit intention that they be available for the deceased in some future state of existence. The caches of objects buried in the ground by various cultures across history, whether deliberately deposited or abandoned in flight, have functioned as accidental time capsules that the present has opened. The deliberate time capsule in its modern form, sealed with an explicit address to a specified future date, dates to the late 19th century, and there are now an estimated 10,000 of them buried around the world, most of which have been forgotten by the people who buried them. The practice has a specific and revealing structure. It involves a speaker who cannot be heard by the audience they are addressing, a message sent to recipients who cannot reply, a gift that cannot be acknowledged by those who receive it and cannot be recalled by those who gave it. The time capsule is a communication that violates the basic structure of communication, which involves the possibility of response. There is no dialogue. There is only transmission in one direction, across a gap that the transmitter will not survive to see bridged. This one-directionality is what makes the time capsule resemble, in its structure, both prayer and the casting of a message in a bottle into the sea. The prayer is addressed to an entity who may or may not exist, and who may or may not respond in any form the prayer can recognize. The message in the bottle is addressed to whoever finds it, which may be no one, which may be someone who finds it too late for the original context to be meaningful. All three involve the human practice of speaking into a gap that cannot speak back, of extending the self into a time or a place that the self cannot reach, of making contact or attempting contact across a distance that by definition cannot be closed from the side of the one reaching. The contents of time capsules reveal what people in any given period believe is worth preserving and what they believe will be lost. The newspaper assumes that the future recipient will not know what was in the news on the day of the sealing, which is correct. The coins assume that the future recipient will find the material objects of the period interesting as artifacts, which is usually correct. The letter assumes that the future recipient will want to know what it was like to be alive at this moment, which is the most interesting assumption, because it implies that the texture of ordinary experience is something that time erodes in ways that the physical record does not capture. The letter is trying to send something that the newspaper and the coins cannot send, the feeling of being here. The physicist and the historian of time would note that the time capsule represents a fundamental asymmetry in the relationship between the present and the future. The future is inaccessible from the present in a way that the present was accessible from the past. The people who will open the capsule can in principle know a great deal about the people who sealed it, through the record that the intervening years will have produced. The people who sealed it cannot know anything about the people who will open it, because those people do not yet exist, and the information about them has not yet been generated. The capsule sender is addressing an unknown. The capsule receiver is reading a message from someone they could research. This asymmetry is the same asymmetry that gives time its felt quality of passage. The past is known in ways the future is not. Memory reaches back and finds things there. Anticipation reaches forward and finds only possibility. The time capsule literalizes this asymmetry by making it explicit, by creating a physical artifact that embodies the human relationship to future time. The capsule is the material form of what the human being is always doing in relation to the future, speaking into it, sending things forward, hoping that something of the present will survive the passage into the time that cannot yet be inhabited. The theological structure of the time capsule is worth naming directly. The time capsule is addressed to an entity, the future recipient, who does not yet exist at the time of the addressing. The capsule sender is speaking to someone who will come into being. The hope that the message will be received and understood and valued is a hope that cannot be confirmed during the lifetime of the sender. The sender must trust, without evidence, that the future will be a place where someone will be there to receive what is sent, that the gap will be bridged, that the reaching will find something to reach. This is structurally very close to what faith is in the religious sense. Trust extended across a gap that cannot be verified. Hope directed at a future that cannot confirm itself from here. The letter in the capsule that begins with, "You are reading this in a future we cannot imagine," is making a bet. The bet is that there will be a future, and that it will contain readers, and that the readers will be enough like the writers that the address will be legible, that the language will persist in something like its current form, that the objects chosen to represent the present will be recognizable as what they are. The bet is almost always placed without adequate consideration of how often it fails. The civilizations that buried their objects did not always produce successor civilizations capable of receiving and understanding what was buried. The languages that seemed permanent have become illegible. The contexts that seemed obvious have become opaque. But the bet keeps being placed. The cylinders keep being sealed. The letters keep being written to the unborn, not because the bet is always won, but because the placing of it is itself the thing, the act of extending the self into a time it will not inhabit, and saying, "We were here, we thought of you, we hoped you would find this," and that finding it would matter, in the way that being found always matters to the one who was looking. Chapter 23. The oldest light you will ever see. There is a star in the sky tonight. You can see it with the naked eye on a clear night if you know where to look, though most people who see it do not know its name or its distance or its history. The light that enters your eye from that star left the star a very long time ago. Not the light from last night or last year, light from hundreds of years ago, or thousands, or in some cases millions, depending on the star. The star produced that light at a specific moment in its history, and the light has been traveling through space since that moment, at the speed of light, which is the fastest anything can travel, and it has arrived at your eye tonight after a journey of a length that the imagination can gesture toward but cannot fully inhabit. The star that produced the light may no longer exist. This is not a possibility or a statistical concern. For some of the stars visible to the naked eye, and for the vast majority of objects visible in telescopes, it is a straightforward fact that the object being observed is no longer there. The light that arrives is the last message from something that ended long before the light was received. The supernova that destroyed the star occurred while Rome was building its empire, or while human beings were still learning agriculture, or before human beings existed at all. The destruction was real and total, and occurred at a specific time in the history of that region of the galaxy, and the information about the destruction has not yet reached us. The light from the destruction is still traveling. When it arrives, we will see a new bright object in the sky, and it will be the news of something that happened before civilization began. Looking at the night sky is therefore an experience that is temporally more complex than it appears. The sky as it appears is not the sky as it is the sky as it was, at many different past times simultaneously, because different objects are at different distances, and the light from each has been traveling for a different length of time. The nearby moon reflects light that left the sun about 8 minutes ago and bounced off the moon about a second ago. The sun you see is the sun as it was 8 minutes ago. The nearest star beyond the sun is 4 light years away, which means the light entering your eye left it 4 years ago. The stars in the Andromeda galaxy, faintly visible as a smear in dark sky conditions, are sending you light that left them 2.5 million years ago. The most distant objects visible through telescopes are sending light from billions of years ago, from a time when the universe was a small fraction of its current age. The night sky is not a view of space, it is a view of time. A single upward glance takes in objects from thousands of different moments in the past, all arriving simultaneously at the eye, creating an experience of the present that is composed entirely of the past. There is no now in the night sky. There is only then arriving now, from different distances, from different depths of time. The specific poignancy of looking at a star that no longer exists is the poignancy of a message from the dead that arrives before the news of their death. You receive the letter before the telegram. You read words written by someone who does not know they will not be there when you read them. The star produced the light in the normal course of its stellar life, burning hydrogen into helium, existing in the way that stars exist, unaware in any relevant sense that the light it was producing would one day be received by eyes on a small planet orbiting a different star. Eyes that would not yet exist for hundreds of thousands of years. The light was not a message, but it has arrived as one, and the one who sent it is gone. The physicist Carlo Rovelli has written about what he calls the present that does not exist. In physics, there is no global present moment. There is no single now that encompasses the universe. Different regions of the universe are in causal contact with each other only across time, because light takes time to travel, and no information can travel faster than light. The now of a distant star is not synchronous with our now in any physically meaningful sense. When we say that a star exists now, we mean that we expect it to exist at this moment based on the fact that it was sending us light for the amount of time it would take the most recent light we have received from it to reach us. Our expectation may be wrong. The star may have ended. The news has simply not arrived. There is a specific relationship between this fact about light and the experience of grief. Grief is frequently described as the delayed arrival of the reality of loss. The person you loved is gone, and you know they are gone, and you proceed through days that contain this knowledge. And then something happens, a smell, or a sound, or a quality of afternoon light, and the knowledge becomes real in a way it was not real before, and the grief arrives with a freshness that the time elapsed since the loss seems unable to account for. The grief was always there, in the way that the light from the dead star was always coming. It just had not arrived yet in the form that the nervous system could receive and process. The loss was real at the moment of the loss. The grief arrives on its own schedule, which does not correspond to the schedule of the loss. Looking at a star that no longer exists is a form of grief for something you never knew was gone. You did not know the star. You cannot mourn its specific characteristics, its particular history, the qualities that distinguished it from other stars. What you grieve without knowing you are grieving is the general fact of its absence. The light that reaches you is beautiful, and the source of the light is not there. The experience and the reality are out of sync by a distance measured in light years and a time measured in human civilizations. You are receiving something real from something that is no longer real. This is the structure of a great deal of grief. The receiving continues after the source is gone. The oldest light you will ever see comes from the cosmic microwave background radiation, the afterglow of the Big Bang, which is visible as a faint signal in all directions, and which represents the universe as it was approximately 400,000 years after its beginning, when it had cooled enough for atoms to form and light to travel freely through space for the first time. This light is everywhere. It is the background of everything. It is the universe looking at itself from the beginning, sending itself light that took 13.5 billion years to arrive. You are in the light from the beginning of everything. The beginning is not past in any simple sense. It is arriving. It has been arriving since it happened. It will be arriving until the universe ends. The stars do not know you are watching. The light does not know it has arrived, but something in you knows what it is receiving. When you look up into a sky full of messages from things that were, before you knew, they were gone. Chapter 24. The present moment and how long it lasts. There is a question that sounds simple enough to be answered quickly, and that becomes less answerable the more carefully it is examined. How long is now? Not how long is a day or an hour or a second, or any of the conventional divisions of time that the clock and the calendar provide. How long is the present moment? The moment you are in right now, the moment that is happening as distinct from all the moments that have already happened and all the moments that have not yet happened. That moment, how long does it last? The first response is that it lasts exactly as long as the present lasts, which is either circular or it is pointing at a genuine difficulty. The present is defined by contrast with the past and the future. The past is what has already happened. The future is what has not yet happened. The present is what is happening now. But happening is a temporal concept. Things happen over time. A happening has a duration. If the present is what is happening, then the present must have a duration. Something must be occurring in it for it to be the present, rather than just the boundary between past and future. But if the present has a duration, where does that duration sit? The past part of the present is already the past. The future part of the present is still the future. If the present is 3 seconds long, then 2 seconds ago is the past, and 1 second from now is the future. And the present that contains both is somehow spanning a region that includes things that have already happened and things that have not yet happened. The present, given any duration at all, contains its own past and its own future. It is not a pure now, but a smear across time that includes the recent past and the near future. Augustine of Hippo confronted this in the 4th century with a directness that remains unsurpassed. He asked what time is, and answered famously that if nobody asks him, he knows what it is, but if he wishes to explain it to someone who asks, he does not know. He then examined the present specifically, and arrived at the conclusion that the present of past things is memory, the present of present things is direct apprehension, and the present of future things is expectation. All three of these are present in the present moment. The present is not a point. It is a thickness of experience that contains the just past in memory, and the about to happen in expectation, and the actually happening in what he called the present of present things. This is not just a theological observation. It corresponds to what psychologists have identified as the specious present, a term introduced by the philosopher E.R. Clay in 1882 and developed by William James in his Principles of Psychology. The specious present is the span of time that feels like the immediate present, the now that is directly experienced rather than remembered or anticipated. James described it as a saddleback, with a certain breadth of its own, on which we sit perched, and from which we look in 2 directions into time. The saddleback is the experienced present. It is not a point. It has width. The width is the duration of the immediate experience. The neurological substrate of this was investigated by the psychologist and neuroscientist Ernst Poppel, who found that the brain integrates sensory information across intervals of approximately 3 seconds. Events within a 3-second window are experienced as occurring simultaneously, or as belonging to a single present moment, even when their physical timing differs. Events separated by more than about 3 seconds are experienced as belonging to different present moments. The 3-second window is not a hard boundary, and varies across individuals and conditions, but it represents an approximate integration period within which the brain assembles its experience of the present. This means that the present moment, as neurologically constituted, lasts approximately 3 seconds, not the infinitely thin line that the mathematical idealization of the present suggests. 3 seconds of integrated experience assembled from sensory inputs that are themselves delayed by the time it takes neural signals to travel from sensory organs to processing centers. The present you experience is not the physical present. It is a reconstruction of the recent past, assembled with a delay of tens to hundreds of milliseconds, and integrated across a window of approximately 3 seconds, and presented to consciousness as the present moment. The mathematician and physicist Hermann Minkowski, who reformulated Einstein's special relativity in geometric terms, described the present in his framework as a 3-dimensional space that exists at an instant of time. In the Minkowski spacetime picture, the present is a spatial slice through the 4-dimensional structure. It has 0 thickness in the time direction. It is mathematically the infinitely thin boundary between past and future. Events on this boundary are simultaneous in the relevant frame of reference. Events to the past side of it have already occurred. Events to the future side of it have not yet occurred. But the relativity of simultaneity, which Minkowski's formulation makes precise and vivid, means that the present as a spatial slice is observer-dependent. Different observers in relative motion define different spatial slices as their present. The events that are simultaneous for one observer are not simultaneous for another. The present, far from being a universal feature of the universe that all observers share, is a local and frame-dependent concept. There is no universal present. There are only the local presence of individual observers, each defined by their state of motion. What the physics and the neuroscience together suggest is that the present moment is not a feature of the universe that the universe possesses independently of the observers in it. It is something that observers construct, partly from the physics of their situation and partly from the neural processes that assemble sensory information into experience. The present is neither infinitely thin nor possessing any fixed duration. It is the integration window of a particular kind of processing system, superimposed on a physical universe that does not have a present in the observer-independent sense at all. For the time travel thought experiments that have occupied this series, the present is the home base, the location in time from which the journey departs and to which the return is aimed. But the present, on closer examination, is not the fixed and stable point that the phrase home base suggests. It is a moving window, a 3-second integration period, a locally defined slice through a space-time that has no universal present, a construction that each conscious being assembles in real time from the recent past and the near future and calls now. The now that you are in right now is not in the universe, it is in you, assembled from the last 3 seconds and the next fraction of a second into the experience of this moment, which is thicker than a point and thinner than you imagined, and moving forward at exactly the rate that everything else is moving, which is 1 second per second. Chapter 25, The Only Direction That Matters. There is a moment happening right now that will not happen again. Not a version of it, not something similar, not the general category of experience that this moment belongs to. This specific moment, with its specific texture and its specific configuration of everything that is present in it, the quality of the light, and the particular tiredness or wakefulness of the body, and whatever is audible, and whatever is felt, and whatever is moving through the mind as these words arrive. This specific arrangement of the world has never existed before and will not exist again. It is occurring once, in the only direction that time moves, and when it has passed, it will have passed in the way that all the moments in this series have passed. Into the fixed past, into the block universe's permanent record, into the state of every particle that was touched by its occurrence, into memory, where it will be reconstructed imperfectly and incompletely, and with the fingerprints of every subsequent moment that did the reconstructing. The series that ends here has traveled through a great deal of territory. It has visited the physics of time's arrow, and found that the arrow exists, but the physics does not fully explain why it points the way it does. It has visited the grandfather paradox and found a loop that cannot close consistently, a causal structure that undermines itself, a puzzle that the best available resolutions dissolve rather than solve. It has visited the block universe and found that all moments are equally real and equally present in the four-dimensional structure, that the 7-year-old version of you is as actual as the version reading this, that the dead are not gone, but located at different coordinates. It has visited the twin paradox and found that time genuinely moves at different rates for different observers, and that the difference is not a matter of perception, but of physics. It has visited causal loops and bootstrap paradoxes and the Fermi problem of the absent tourists and the butterfly that ended civilization and the specious present and the oldest light in the sky. All of this is real. The physics is real. The paradoxes are real. The questions they generate are genuine questions that have not been fully answered and may not be answerable with the tools currently available. The universe is genuinely stranger than the ordinary experience of a day suggests. Time genuinely does not behave the way it feels like it behaves. The past is genuinely preserved in ways that the word gone does not capture. The future genuinely exists in the block, though it cannot be accessed from here. The present genuinely has no fixed duration. The arrow of time genuinely points in one direction for reasons that the physics of individual particles does not require. And at the end of all of this, the thing that remains is not a theory. It is not a resolution of the paradoxes. It is not a cleaner understanding of what time is, though the series has offered some of that. What remains is the moment, this one, the one that is happening now, at whatever hour and in whatever place and in whatever state you are reading this. The moment that the arrow of time is pointing through, the moment that is right now becoming the fixed past that all the physics says cannot be revisited, and that all the time travel thought experiments have been trying, in their various ways, to find a way back to. The philosopher and contemplative traditions across cultures have arrived at something that the physics is now beginning to approach from a different direction, not by solving the same problem, but by finding that the deepest engagement with the nature of time produces as one of its destinations the importance of the present moment, not as a consolation prize for not being able to time travel, not as a second-best option chosen when the physics rules out the first, as the genuine conclusion of a serious engagement with what time is and what the present is and what it means to be a conscious being moving through time in the only direction available. The Stoics called it the discipline of the present moment. The Buddhist traditions call it mindfulness, which is a translation of a word that means something closer to remembering to be here. The Zen tradition generated an entire aesthetic and philosophical culture around the quality of attention that is available when the present moment is fully inhabited. Proust spent a lifetime trying to recover the past and discovered that what he was actually looking for was available in the present, through the specific quality of attention that certain kinds of sensory experience could unlock. The mystics across traditions who described their deepest experiences as timeless were not describing the experience of all time at once. They were describing the experience of being fully in the present, which has a quality of timelessness because it is not divided between memory and anticipation. The time travel paradoxes, taken together, are partly a series of demonstrations that the past is inaccessible and the future is inaccessible, and the present is where everything that can be experienced is experienced. The grandfather paradox says you cannot change the past. The block universe says the past is real, but not reachable from here. The chronology protection conjecture says the laws of physics may prevent access to the past entirely. The butterfly effect says that even if access were possible, the specific past you are trying to reach would be altered beyond recognition by the attempt to reach it. The many worlds interpretation says that the past you might visit is not the past you came from. All of these, from different angles, say the same thing. The past is not where you are. The future is not where you are. Here is where you are. What presence actually means as a practice, rather than as a concept, is something that this series cannot deliver, because it is not a matter of understanding. The paradoxes can be understood, or at least approached. The physics can be learned, or at least gestured at. The philosophical implications can be traced. But the quality of attention that makes the present moment fully inhabited, rather than merely noted, is not a matter of knowing more about time. It is a matter of being in the moment that is happening, rather than in the moment that was or the moment that will be. This sounds simple, and it is not simple. The mind trained by evolution and by culture is a mind that is always partly elsewhere. In the past, reviewing and revising and regretting. In the future, anticipating and planning and fearing. In the narrative, constructing the story of what is happening, rather than simply being in what is happening. The pull away from the present is constant, and is powered by the same cognitive machinery that makes planning and learning possible. The present is where experience occurs. The rest of the mind's time is spent on everything except the present. The arrow of time points in one direction. It points through this moment. It pointed through the moment before this one, which is now the past, which is fixed, which is in the block at its coordinates, which is as real as this moment, and not here. It will point through the moment after this one, which is now the future, which is not yet determined, which is not yet anywhere, which will be exactly as real as this moment when it arrives, and will arrive having been pointed to by the same arrow that is moving through now. The arrow asks nothing complicated of you. It asks only that you be in the moment it is passing through, which is this one, which will not come again,